and 10,000 output weights was supposed to be fixed. Where is output weights? Yes. Output weight was supposed to be set. Okay, we got the problem. The problem was here.
Screen sharing, sir?
No. Yeah, I can share the screen. The problem is somewhere here. So my output weights is not set properly. Yeah, so we are trying to get this here. The problem was here. So it was not inversing. So inversion was not happening for one dimensional data. So it is not taking for one dimensional data. It requires two dimensions. So we had to check if the dimension is only one, if the input is only one, then we might have to just resort to plain linear regression. Otherwise, so it clearly says here there is a problem. So array must be two dimensional if I want to find inverse. I cannot find inverse of a vector. I can find inverse of a matrix. When there is only one variable, the matrix is not there, it cannot find the inverse. That's what it is trying to tell. So basically we were not wrong. We have not used the properties of the matrices. So there is no inverse for a one dimensional array, because when I give only one dimensions, here I am giving x as one dimension only 10 records. So everything is good, but my xt is not good. So x is only one dimensional array, it has no inverse. That was the error. So how about yours? Was it working? This was working for me. A two dimensional thing was working for me. So was it working for you? Has anybody tried it? No, yes.
Sir, are you talking about the Jupyter notebook which you shared?
Yes, Jupyter notebook which I sent you,
Okay, so I
ELMR.
ran, yeah, I ran and it was coming like 1.34.
1.34, let me check mine. 1.34, yes.
So
Yeah,
same came for me.
same. Okay, so no problem. Let us get on to the second problem here. So let me work this out. Anyway, this will not be useful for me. Only this will be useful for me. But anyway, let me keep this. This will be one of the things that we would like to save. We will save this copy, untitled one, and then we will see. We will open up one more, and we will call that as ELM classification. So one of the problem we were seeing was if we have the numeric data, it's okay, we can use regression. But what happens, as I was discussing with you, if my data is something like this, right? So it is something like this. Can I use classification here, or should I use regression here? Because basically there are two clusters. I would like to classify this into this or this. How can I classify this? Still it is a line, or it may be lines, we really don't know. In fact, if you take this an XR problem, it is called as support vector machine. We will not get into the details, right? If it is only one, it's a neural network, and the ELM or neural network can do both. So support vector machine is a special case of neural network where only two lines, two planes will be identified. That's the principle of SVM. Though you can go to details and others, we will not work on SVM, right, which is one of the important algorithms in machine learning, support vector machines. It is nothing but a neural network for us, right? The second way in which we can classify this is to find any number of things. Now I have two, I have x1 and x2, and I would like to build my classifier. I will use all the variables, I mean hidden nodes, and I would like to classify here. So let me not put everything, I will put this as my input node, and this as my hidden node, this as my hidden node, and this is my output node. So I have defined my input node, my output node, and now they are connected. They are fully connected. Fully connected in the sense every neuron in this layer is connected to every neuron in this layer is connected to every neuron in this layer. So that is what we call as fully connected layer or dense layer. Now if we do this, there is a problem. The problem here is y is either 0 or 1. This is a big problem. Either it belongs to this or it belongs to this, it is not in between. There is nothing called as 0.2, 0.9 like that. What is the way if I get -1 to 1? So anything between -1 to 1, right? If I get this value for y, how do I handle that? How can I say it is 0 or 1?
Using absolute value.
Yeah, absolute value. Now I will give x1 and x2. x1 is equal to some value, x2 is equal to some value, and I have y. Now I have learnt it. My y can be 0 or my y can be 1. But my y cap looks like it is 0.4, it is 0.4 or it is 0.9. Now, how do I know whether it is correct or not? Some value of x1, xy, right? 1, 2, 3, 4, whatever it is. So values are there. We have y value and we have y cap value. After learning the model, I will predict what is the y cap given x1 and x2. So if this is given, how do I know it is 0 or 1? Because it is giving me 0.4 and 0.9. How can we make meaning out of
Activation
it?
function, sir.
Sorry?
Activation.
Yes. So we had to use an activation function. Basically activation function means, so either it belongs to this cluster or this cluster, right? It says it belongs to this cluster by 4 and this cluster by 6. Basically I would like to see something which is an activation function. I would like to say that anything less than this value is taken as this cluster, anything more than this value is taken as this cluster, and it can be a simple activation function like a thresholding. So I will do a threshold and I would like to detect it.
Is an activation function set of rules?
Activation function can be set of rules, it can be a mathematical formula, it can be anything.
So I think threshold is the more suitable term to use because so suppose I have a range, right? I have a range. So value is between suppose 0 to 1, and I have a 1000 record. So here length is 1. Then I can divide the length by 1000, and for each value or item, I can iterate 1000 times by incrementing 1 by 1000 times each, and then I can check for each value of x whether it is what is the value of y cap. Then accordingly, based on the threshold, I can distribute it in either of this 0 and 1 category.
Yes, actually we will apply the threshold only. So this threshold is nothing but some kind of line. At what point of line, right, this is likely to be some color. Okay, let us change this. Let me change this to red color. So this is my line, isn't it? This is my line. At this point, right, if it is more than this or if it is beyond this, it is this. If it is less than this, it is this. Now this line, how do I set this line? That is the gradient descent. This line can be here, this line can be here, this line can be like this, right? So anything can be there. Whichever gives maximum classification accuracy is what we are taking as threshold or the gradient descent. It is a search problem. So what we would like to do now, I would like to set basically I will set if it is less than 0.5, if the y cap is less than 0.5, right, new y cap, let us call this as y double cap, right. If it is 0.5, it is 0, less than 0.5. If it is more than 0.5, it is 1. We have resolved the problem by thresholding it. You are getting the idea. When I predict something, I may get numeric value, but numeric value is not what I am expecting. I am expecting the outcome of my predictive algorithm should be it belongs to class 1 or it belongs to class 0. But what I am getting is the values like this.
Sir, I
Yeah.
have one question here.
Yes.
Okay, so basically, see what we are doing here. We are classifying y as 0 or 1, correct?
Yes.
And here, if you see Ax, what I understood here, Ax is continuous data, like 1, 2, 3, 4. It
It
can be
can be continuous, it can be categorical, doesn't
right, right.
matter. Yeah.
Yeah, yeah, sir. See now based on then we are calculating the y cap. Yeah. So now y cap is in the range of 0 to 1.
Yes.
Yeah. So
It can be 0 to 1, it can be minus 1 to 1. If it is not scaled, it can be minus infinity to plus infinity. Doesn't matter. So we can scale it or we can unscale it, right? Without scaling, we can use. With scaling, we can use. If it is with scaling, it will be between minus 1 and 1. It can be between 0 and 1. If it is not scaled, it will be between minus infinity to plus infinity.
yeah. So basically, what I'm trying to say, sir, if it is categorical data, we can directly distribute it in 0, and on that time, it is not required to calculate this y cap, right?
Oh, sometimes what happens is we may have mixed type of data. Also, just categorical data, building a regression model is pretty difficult. Normally, we go for a decision tree kind of thing. That is another thing
Exactly.
that you have to keep in mind. Whenever
Mm.
we have mixed type of data or categorical data, don't use k-means, neural network and linear algebra algorithms. Linear algebra algorithms are very good when data is numeric or mixed type. So mixed type means you have to convert that back into the numeric data by converting that using one not encoding. But in decision tree, one not encoding is not needed. You can directly go for decision tree.
Yes, yes, yes.
So when if you ask me, my current favorite is XGBoost. Irrespective of whether it's regression, classification, fraud detection, anomaly detection, anything, apply the same hammer. Right? Categorical data, numeric data, whatever it is, convert every problem into classification or regression problem, solve that using XGBoost is current approach. Right? But sometimes neural network may be giving better result. Without testing that, we may not be in a position to select which is the best algorithm. So you have to run multiple algorithms and see which algorithm is giving good result, which is stable. So if we can get stability and the accuracy, both of them are good, then we can go for selecting that algorithm. Okay. Okay. So now with this concept that we would like to do some kind of thresholding, let us go back and let us start our work. Now I would like to go for same thing. I would like to select all of this and we would like to put it, where is this? This is ours. So we may get all of them. I will close this because it will be too confusing. So let me close this. Now I would like to create some data. Let us see how the data is created. Nothing is changing from here, right? We are creating some data, right? So now I would like to check, right? Simply what we did earlier, I would like to create only two classes, right? This x1 is 1, x2 is 2. So just we would like to create x and y. Now let us take this and try to put it here. So what we are trying to do is, so first 5 are NP zeros, next 5 are NP ones. So let us see how it looks like. I will put df is equal to pd dot data frame x with column names I had to add here. Column names is equal to x1 comma x2. So now I would like to see df head, right? Before that, let me add, right, we will add y also here. Df y is equal to y. So now we can look at how my df looks like. My df looks like this. So what is not there? YDF is not defined. Okay, yes, possible. We never defined it. Items passed. So columns is equal to x1, x2, x is okay. X1, x2 is okay. Key error y. Where is
So
this?
df of y equals to df of head, I think. This is
Ah, thank you, thank you. So this is equal to actually y. Right now we can get df of head of df. Right now we have head of df is equal to, if these are the things, or let us put everything. Now we'll see for what values of x, for what values of y. Right, if these values are there, this is 1. If these values are there, this is 0. Now we have a clear picture. Now let us implement, let us see whether Sn is there. So SNS is not there. Let us import SNS. We'll import SNS born as SNS. Right now I would like to visualize my data. I would like to visualize SNS dot pair plot df. So now we can visualize it. It shows me blah blah blah. Right, it tells me how it looks like with the distributions. Yes, the distribution is looking good, and some kind of classification is happening here. It belongs to two classes. Now we would like to see if I color it. Right now I would like to say SNS dot pair plot of color can be given for the points, that is called as hue. Hue is based on y. Right now let us look at how the y looks like. Right now if you look at x and y, can you clearly differentiate when the x2 is greater than 2, it is likely to be cluster 1 or class 1. When it is x2 is less than 2, it is likely to be class 0. Can you see this? There is some overlap, but we want our neural network to learn this, to classify this like this. Yeah, so this exactly is the problem we are trying to solve now. Now let us look at what is that we would like to take. Like we were looking at x shape and y shape, we can look at it, right? And we get print x shape and print y shape. If you look at it, let's add this as x and y. So my x is much, my y is this much, my y is this much. So okay, gamma has to be given. So we get x is 10 by 2, 10 rows 2 columns, and y is 10 columns. So we got it now. So once we do this, rest of the things I would like to do the same thing. I would like to set the input size. How many inputs are there? How many inputs are there? 1 and 2. I would like to divide input size as x shape 1. This is x shape 1, which is 2. And hidden size, I am setting the number of hidden nodes as 100. Right. Now I would like to take the input weights. So input weights and biases are computed randomly, or assigned randomly. So this is the difference between the ordinary neural network and extreme neural network, or the random neural network. So we randomize it. Then what we would like to do, we would like to do some kind of ReLU, right, which is the activation function. It is nothing but linear. Right now you can give some kind of thresholding, you can use tan h, you can use sigmoid and other things, you can test it later, but as of now we will go with ReLU only, right. Then we would like to get the G and H. G is the internal one, which is computed as W into X, right, plus bias, and H will be thresholding G, which is nothing but our ReLU function. So once I do this, I would like to get my neural network, right? How my neural network looks like, right? So my neural network is optimized for the given values. Now output weights are there. I can see, I can print the weights and I can see how it is looking like. All the 100 weights are there. Now I would like to create a prediction function, right? How can I use neural network to predict? I can run this, right? It is nothing but hidden nodes into H. I have to compute that and I will put that. So I will put this. Ta-da, ta-da. So let us go ahead with this. So I will pass X and I would like to look at, now I will build the prediction, right? So I will get the prediction, I will print the predictions. Now look at the predictions. So prediction says -2, -5 to the power of 16, things like that, which may be 0, 0, 0, and some of them may be 1, 1, 1. But if we look at it, all the prediction values, all the output values are float by nature. They are floats, right? So now if we are looking at the floats, right, we have to convert it in some way, right? So what I will do, I will try to get all of them, right, for value in prediction raw. If value is less than 0.5, right, then print 0, print 0, print 0, else print 1. So let me print this and see print 1. So now I can see for first 5 it is printing 0, for next 5 it is printing 1. Now I would like to capture this in classification, right? Class prediction, how it is predicted, right, is equal to nothing. Now I would like to add this 0, right? Append class prediction append, class prediction append, right, is equal to sorry append 0, right? Otherwise I would like to take this and class prediction append, right, class prediction append 1 when it is more than 0.5. So I will append it as 1. Now I can print class prediction. I can print class prediction. Now I can see some of them are 0, 0, 0, 1, 1, 1. Now I would like to add this class prediction to my DF. So my DF prediction, right, is equal to class prediction. I will do class prediction, class is predicted here. Now I can see df dot head with all 10 values. Let us see, right? So this is my kind of actual value and the prediction. Now I would like to see how good is my classification. So if we want to test how good is my classification, we go with certain measures. Let me remove all of this. So the first measure is called as confusion matrix. So what is confusion matrix? Now let us understand what is confusion matrix with some example. What are the actual values? What values are there in actually? It belongs to 0 or it belongs to 1, isn't it? What is your prediction? Your prediction will be 0 or 1, right? Now whenever I predict it is 0, if it is actually 0, it is called as true negative. because 0 is not of interest, 1 is of interest. When you predict 0, but actually it is 1, it is false negative. Actually this is not negative, but it is predicted as negative, that is why it is false negative. Now let us predict it is 1, but actually it is 0, it is called as false positive. It is called as false positive, right? You predict 1, actually it is 1, it is called as true positive, isn't it? Will you agree with me?
Yeah.
Right? A simple example is you bring a carton of mango to your home, right? You will sample the mango and it is very sweet. When you bring home, all the family members eat the mango, it is very sweet. It means that your assumption that the mango I ate during sampling was sweet and all the mangoes are sweet. Your prediction is all the mangoes are sweet. Actually mangoes are sweet. Actually mangoes are sweet. Your prediction is correct. All the mangoes are sweet. That will be your true positives. Now you predict that it is sweet, but only about 90 mangoes are sweet. 10 mangoes are not sweet. How many false positives are there? You bring 100 mangoes, right? 90 are sweet, right? And 10 are sour. How many false positives are there?
10.
10 false positives are there. Same thing, right? You eat something and you feel it is sour and you say that no, it is not good. But your wife insists the color, the smell and other things are good and you will take it home. When you open it up and eat, right? All of them are sweet. It is true negative. You predicted that it will be false, but actually it is true, and that is true negative. Now you predicted it is 0, right? But actually it is kind of no, I mean it is you predicted it is sour, and actually they are sour. It is true negative, right? But your prediction is sour, and all of them turns out to be sweet. It is false negative. Anything, you can take anything, and this is what we call as a confusion matrix. And this is one of the important tables we use. Normally our expectation is maximize true positives. True positives should be increased, right? Minimize false positives. False positives should be minimized, right? We will go to corona testing, and I can pay and I can bribe them and get positive negative certificate. But let us say that 4 times when you go, all the 4 times it says it is positive, but actually when we go for genomic testing it says it is negative. Then what was RT-PCR test? Was it true positive or false positive?
False positive.
It is false positive. RT-PCR false positivity is very high. It's about 20%. So that's why generally we used to say that unless you have comorbidity, there is no need for you to go and get tested unless government mandates. So that's why we don't vote, because unless government mandates, if you don't vote, I will not give you XYZ, we will go and vote. But whom do we vote? Because recently I was listening to some gentleman. He said that democracy is a beautiful thing. It is of the people, by the people, for the people. So, but the problem is people are not intelligent. Right now, you can say that they are dumb people. Right, our democracy now becomes by the dumb people, for the dumb people, of the dumb people. So it cannot be better than that. Right. So looking at that, it is very much necessary whether a particular thing should be believed or not, and that belief comes from false positives. How many false positives are there? In fact, we believe in Indian constitution, India and things like that, because though we have a lot of hypocrisy, there is at least 1 or 2% who can hammer the truth. That is good enough. The true positive rate can be 2%. It can be improved to 4%. but there is a true positive thing in India. So that's good thing. But the false positive rate has to be reduced. Always we have to reduce the false positive rate. Most of the time we are not bothered about true negative and false negative because that is not of interest. Somebody who is going to leave my company, I am interested. Are you interested in somebody who is not going to leave your company, or you are interested in somebody who is leaving your company?
Is leaving the company.
Right, especially if it's a high performance resource. Are you interested? And you say no, if he wants he can leave, it becomes government. Actually if you see, all government has got false negatives, because I assume he will not do, his performance is bad and everybody's performance is bad. Yesterday Madras High Court has given a opinion that 90% of the police are corrupt. You ask any police officer, he says no, they are the best in the world, but they will not go through the truth serum. No narco test for police. Even court agreed that no narco test for police, but court itself says 90% of the police are corrupt. Right? So your prediction will be correct. It is false negative. I mean true negative. It's a kind of very true negative, not false negative. All of them are corrupt. So 10% still there who are capable of doing. That is the solace. So in any case, the idea for you is increase true positive. We are not bothered about true negative unless it is also one of the important factors. But in 80% of the cases, only true positive is a important factor. Now let us look at this. Now the class belongs to 0 or the class belongs to 1 is actual. Actually this is what is likely to happen, right? Now what my system says, right? How many of them are 0? How many of them are 1? By prediction. I am going to predict it. My prediction, right? Now let us look at our results. How many of them are 0? Actually y is 0, prediction is 0. 5, right? 1, 2, 3, 4, 5, where you predicted that it will be 0 and prediction is also 0. 1 is our interest. We will take this as true negative. So our true negative now is, if you look at our true negative, right? You predict 0, actually it is 0. We will get all 5 of them are correctly classified. How many you predicted as 0 and actually 1? 0 of them. Now look at 1. How many? Actually 5 ones are there.
Yeah,
All 5
all.
are correctly predicted
Yeah,
as 5.
yeah, all of them.
Right? Now all of them, right, are 5 are correctly predicted. How many of them are predicted as 1? Actually they are 0. 0. This is the confusion matrix for us. This is the confusion matrix for us.
But sir, real world data never happens. I mean, real world data, real world
Absolutely.
data.
No, yeah. Real world it never happens. This is a toy example, right? We wanted to understand how it is working.
Right.
Real world it happens like this. 10%, 90% you are correct, 10% you are false. There are some good officers. There are some good, police people. Very effective, very honest, very dedicated and things like that. So it's correct. You are not 100% correct on predicting all police are corrupt. No, court has declared officially that 90% are corrupt. The problem is we don't know which is that 90%. Who are they? Is it from IGP to the last man, the constable who recently recruited, or is it some people? We really don't know. And the thing is, AI is likely to help in all those areas. But we have a problem. In India, AI is the last thing that we want, because we want everything to be supported. For us, we are very clear. You allow AI to happen, we will give 20,000 salary per person whether he works or not. But they are not interested. They do not want that. They want power. They do not want prosperity. So always it happens. In fact, universal basic income is possible whether he wants to do it or not. That's the way we should go. Make AI possibility. Let AI do everything. You go, you study literature, you study XYZ, you study medicine, you study whatever you want. Let AI do the work. No. Who are you to tell? I am the Prime Minister, I am the Chief Minister, I am the opposition leader. None of them are interested in pushing AI. And our NASCOM is very much interested in making resources available for AI to support Europeans and Americans, not to put anything in India. That is the state what we are in. None of us are interested in doing anything in India because basically Indians do not pay for anything, right? I absolutely agree if it is a business sense, but otherwise we would like to look at AI can do this. If not 90%, it can turn it around. 10% of the AI can be corrupt. 90% of AI can be better. But when we proposed a couple of things, what we wanted to see, they said, who the hell are you to do this? One of the things we wanted to do was wherever it is, police cannot catch anybody. Traffic violation, things like that, automatically the money will be deducted from bank. The problem was if police turns out to be that, the money will be deducted from the police account. No question asked. You cannot influence AI. And they foreseen all these things. A judge can be corrupt, a minister can be corrupt. The AI, the moment AI detects it, they cannot accept that they are corrupt. That has created all the problem. Keeping that sad part apart, AI, if used positively, can do wonders. It can do wonders. But I have my own doubts whether in India it is possible or not. Right? Maybe not in my lifetime, but maybe our children may have it. So may see, yes, AI is doing things like that and all. So it should go beyond the caste, it should go beyond the language, it should go beyond anything. So are we in the AI race or not is the question. And you have to decide whether you would like to be in the race or you would like to step aside, get an MTech degree. Never do that. Your competition is world, not India. You can compete at the world level if you are good with AI. Anywhere you can go. Keep that in mind when we are going. But the idea is we would like to get our confusion matrix ready. This is our confusion matrix. Any doubt on confusion matrix? What are we trying to do?
No, sir. At least I am good. But sir, I have one question. What is precision and what is recall?
Yeah,
How to?
normally, yeah.
Yeah.
So let us say that you will get all of them. If you want definition, let's go with the example first. So
Yeah, sir.
precision.
Yeah, example
So,
actually.
let's take an example instead of going for definition and all. So when you throw the dart onto the dartboard, every time it hits the dartboard, every time it hits the dartboard, right? Now let us say that you throw it 10 times, 9 times it hits the dartboard. That is recall. What exactly you are trying to do? You are trying to hit it. You are trying to recall. So recall is 9 out of 10. Now out of that, how many of them, how many of the dart you are thrown is hitting the bullseye? That is precision. So 9 out of 10, did you hit the bullseye? We call you as a sharpshooter, right? 9 out of 10 times, you got that right. You really hit that. Your recall is better. So you are getting the point. The difference between recall and the precision, right?
Yes, sir.
Precision need not have to be bullseye. You hit the same point 9 times out of 10. Your precision is very high. You are precise. You are hitting the same point again and again. But you are not on the mark, right? You are on the mark when you are hitting the board. When you are hitting, let us say that you will throw the dart and dart comes outside the board. All 10 times it is outside the board. Precision is very high. You are hitting the same point outside the board, but there is no recall,
Okay.
right? You are not hitting the board. What is expected? You have to hit the board is what is the expectation. But what has happened here? All 10 times you hit the same point outside the board. You are very precise, but recall is very poor. On the other hand, you have hit the board, but there is no precision, zero precision. And it must be a balance between precision and recall. We try to put it like this. right? Your recall and precision will be given like this. The expectation is for a small recall your precision will be very high. For any recall after this, and this is called as AUROC or receiver operating characteristic curves. So your ROC should be near to 1. So without model, this is my precision and recall. With model, this is my precision and recall. What do you prefer, with AI or without AI? This is without AI. Now let us say this is without AI. If you don't use AI, right, you recollect XYZ and things 10% recall, 10% precision, right, 20% recall, 20% precision. This is a 45-degree line. Now this is with the model. With small recall, everything is good. And after this, everything is 100%. And this is what we are looking at. High precision, right? Better recall. So it's a kind of compromise. That depends on the quality of patterns that are there in the data.
Sir,
So
I have one more question in this case. So when you are saying it is a precision versus recall, so I can also
it is
basically,
not precision versus recall. It's a
yeah,
balance.
balance. So it is basically, I
Right.
can also say it is TPR versus APR, no? True
Yes.
positive rate versus
Yes.
false
Versus
positive.
FP, false positive rate.
Yeah.
So
So
for
there,
minimum false positive rate,
yeah.
I must get highest true positive rate. So you can replace this with FP. What is the FP and what is TP? What is my true positive rate? What should be my true positive rate? For only 10% of the people whom I classify with false positivity, 100% of people should be captured for true positive. Isn't it? You will catch fish. When you catch fish in the net, out of 90 fishes, out of 100 fishes or 100 animals that are coming in your net, if 90 are snakes and only 10 are fish, right? It means that you are here and your precision is here. Your false positives are very high, you are worse than the model. But only for one snake you get 99 fishes, your accuracy is very high, your true positive rate is very high. So it's a kind of balance between false positive and true positive, right? But those are all theoretical. Practically, I would like to maximize my true positives. So if you look at true positives, because most of the times, let us say I would like to send an SMS. SMS will not cost me if the false positive is increasing. But I would like to capture all true positives. It doesn't mean that I would like to score the entire data to everybody. It has been done now. False positive makes sense when there is a cost attached with every mistake that you do. Whenever there is a negative marking, people will think twice before doing anything. Right? Now let us say that you will take the red tablet and the blue tablet. Red tablet will make you rich. Blue tablet will make you healthy. Precision versus recall. True positive versus false positive. What will you do? Clever people will take half of red tablet, half of blue tablet. But that is not necessary. The idea is maximize the true positives depending on what the value we carry. If we are looking at, no, I want to be rich, let me die, but let my children, let my relatives enjoy the fund, probably you may go for red tablet, red pill, which will give you rich, right, which will give you wealth. Probably on the other side, no, let me enjoy health, right, I don't need wealth when I am healthy. So if we cannot purchase my COVID protection even with all the money, what is the use of it? Right. So depending on the value, you can do that. Same thing happens with businesses. So they would like to maximize the true positive when false positive cost is nothing. So in such cases, the model may not be needed. But in some cases, false positives are very important. For example, you are in a discount business. Giving discount to everyone, they will come, they will take and go. But even without giving discount, if he comes, he is the true positive. Can you detect who are those people? Minimize the number of people who will come only if you give some discount. That is not a good thing. To introduce a behavior, it is okay. Look at Geo and others, right? They give it for 1 year free, blah blah blah, and all those things. Now, minimum 199, nothing less than that. Next year it will be 400. right? No BSNL, no Airtel, only Jio. So now if you are taking a phone from me, you have to take power also from me, you have to take gas also from me, and fiber to home also from me. Otherwise, phone will not be given. Right? All those things are there. That's good thing for Jio. I would like to invest in Jio, but that is not a good thing as a monopolistic practice. Right? So looking at that, the true positives and false positives depends on the business case.
So for that, sir, CCI is there, no Competition Control of India. They are moderating that, right?
They are all under cover. No, they will be covered by the lobbies. Can you show any one case where it has said you are not supposed to undercut the price for Jio?
Geo, it is not there, sir. But regarding the big bazaar, there is lot of this thing happening right recently, no.
No, that is because of
Amazon
Jio.
and
No,
yeah,
somebody stronger than Jio is there to fight that. That's why it is going on.
correct. Correct.
So if it was weak, somebody who is a Kirana store owner, he would have been killed in an accident. No way, no way. Let's not have high hopes. I'm Indian, but let's agree that we are hypocrites. Right? We don't tell the truth as truth. Nothing wrong with that. So it will not denigrate us as no, you're bad, things like that. No. When somebody says, what is your Bharatiyata? It is, there was a song, I still remember, Fir bhi dil hai Hindustani. Right? That, completely captures what we are. So we have some truth, we have some lies, all those things are good. Right? I'm surprised if Geo is not there in defense and all those things. The moment they come, then we are Geo India.
I agree, sir.
Right?
That is,
Nothing,
yes, yeah.
nothing wrong with that. I'm not against any of that. We must be capitalistic, but at the same time, we must allow monopolies. So that comes with a
Sir,
lot of other things. No?
honestly, sir, in that way, India is far better place because if you go to Western, either it is strict democratic, and if you go to this our neighbor cities, it is like strict communism. So we are in a moderate position. We are though fighting ourselves,
I
but
don't
I
think
think, yeah,
maybe we have differing opinions. My opinions is India is better than what it was 40 years back, but there is a long way to go.
yeah, that I agree.
I'm okay if Modi destroys all the opposition and controls and makes India better than China and US. I'm happy, but make that.
Yeah, make Singapore. I mean, example is Singapore.
No, you cannot. You cannot make it like a Singapore. If you look at Singapore, we try to make India look like Singapore, Bangalore look like Singapore with multi-story buildings. That is not Singapore. You look at Singapore, there is no reservation.
Hmm.
So it is all meritocracy. People cannot leave. It chokes in Singapore to leave unless you are in the top notch. India, it is not. Even if you study PhD for 25 years, you will be given a room in JNU. Public money will be spent on it. Nobody questions it. And what is the question of somebody doing a PhD for 25 years using public money? Right, after 3 years, he is not, he must be disqualified. But still, we have systems. Nothing wrong with that because it's an inclusive system. No, inclusive system cannot grow. A growth system is not inclusive. It will keep people away. Look at China. 1% of the people own entire country. 99% do not have anything. All those 1% belong to Communist Party. But China is doing lot better. Right? We can say we are
Sir,
Indians
better.
and all.
I'm sorry, but better is a very relative term, sir. I mean, I'm quite, I'm
No,
quite.
no, no, no problem. Go ahead because all of us should have opinions, and my opinion is very clear. I am for
The
India to grow.
better means it is like either I think better is moderate. Better is not extreme. I mean, better is if you say at the end of the day, some people at least in our country, there's the lesser number of people having food in their mouth and they are able to.
Show that exactly. That is what we are asking. But where are you showing it? How
But
do I
if you,
know?
yeah, if you
Your
go like,
PDS system is corrupt. Your distribution system is corrupt.
yeah,
So on one side,
yeah,
yeah,
corruption is really-
that is the problem. No, we are for that. You uplift people. You give them money, right? Make them work. Give them skill. Give them education. Where is that? There is nothing like what is happening. You look at Germany. Germany education is free. In India, is education free?
Yeah. No. Then
No,
in
because
US it is, in US on contrary, sir, it is beyond reach, sir. In contrary, in US it's so
no,
expensive.
you have to look at the university system in US. There are certain groups which are coming out with free university where you can take any course free. Your degree will be free. It happens. It happens. In that way, US is more open than India. Recently, I saw some of the people were telling Nalanda University is rebuilt as it was earlier. So my simple question is, earlier in Nalanda University and Takshila and Vidarbha, there was no reservation. Only the worthy candidates were going there and studying. Is the same thing will be there in the current Nalanda University, or is it only the buildings that will be done, but the same old wine is bought again?
Sir, for that IGNO is there, sir. This Indira Gandhi National Open University.
The court has declared IGNO degree is not valid.
Oh,
What is the use? On one side, you try to have the mullahs and the judges and others who will declare what is good, what is not. On the other side, you try to open it up. Indira Gandhi Open University is one of the best universities. Trust me, the quality of content, what I have seen in their books is excellent.
mhm.
Excellent. Anybody who clears IGNO should be declared better than ordinary universities. But it is not. That is the problem. That is the problem we are fighting. That's okay. We cannot fight the system. That's why we are cynical. Not going out of the system, because I have seen lot of countries where I feel I'm safer in India and Bangalore.
Yes.
I can walk around, nobody knows who I am. But if I go in other countries, I have to carry my passport all the time.
Correct, correct, sir, correct.
So I'm very happy to be in
In
India,
India.
in Bangalore, without worrying about anything,
Yeah,
right?
true, true. Absolutely.
But
Sir,
that will
one
not make
question.
not non-application of AI, right? We are
Sir,
doing AI, and if we cannot apply it in our own country, and if we supply it for some other country, as an individual, I may grow with money, but what happens to my economy? Is not there. What happens to my countrymen who cannot study? In fact, we are doing one of the project in race. It is about teaching first standard kids the language and maths. We would like to make sure that within 6 months, that first standard student is capable of reading, writing, speaking 400 words in the first standard in any way you want. What will you do after 6 months? Let the student play. So if you want, you can participate in that, because we want a lot of volunteers to participate in that. And it's a convergent AI project. We would like to do video analysis, we would like to do audio analysis, we would like to do text analysis, we would like to do learning analytics, where what type of kid will learn how.
that sounds
So I
very
cannot
interesting,
say,
To
sir.
enroll for these projects and all.
sorry.
Now, how to enroll for these projects? Like if I am
you
interested.
you connect with the teams who are already doing it. You can connect with me, you can connect with Shinu, you can connect with Dr. Rashmi or with Mithun, right?
Okay.
Anybody who is from race, you connect with them, right? Currently teacher in machine, video analytics, plenty of projects are going on, but we are
Yeah.
very comfortable or and very fond of the teacher in machine kind of thing, because that's our contribution back to what we got from the society. That's
Okay.
what we call as a social good project. You should do one social good project as a part of our upbringing. Okay, we are giving this back to society without any expectation. We are doing this. All others, yeah, expect as much as possible, right? So it must be experience, it must be money and things like that. But some projects like this, social good projects, most of the, in fact, another project which I am very fond of is, you might have heard about ICD-11 classification systems for medicine. Any disease will be classified, and according to that, the premiums will be set, the settlements will be done. China has got its system called as traditional Chinese medicine, and
Okay.
TCM is recognized in ICD-11, but Indian Ayurveda is not recognized. So that pains us. At least me, it pains me. So we are pushing everybody. Why the hell you cannot do this? Either Ayurveda is completely wrong, right? Stop Ayurveda, just go for allopathy, stop all other medicines, or fight like Chinese and make sure that WHO accepts Ayurveda as one of the alternative medicines and includes it in ICD-11. Nobody is there. They will
Sir,
talk about everything.
Ayurveda is definitely not wrong. The very reason I can tell you, Even today in today's date in West, some of the medicines that they are selling, they are using a medicine, the ashwagandha, they are including that and they are selling. That is, they are one of the, I mean, the what can I say? The selling, the ad is
No,
like it's like,
that's
yeah.
we all know, but we don't have backbone to stand and fight back. Individually, we are using Ayurveda, right? Ayurveda simply says your food itself is a medicine. Eat the food right, everything will be okay. In that way, we are living Ayurveda. So it clearly defines during which season, what type of food you have to eat, at what time you have to eat, how much you have to eat. Everything has been codified, and they say that it can be calibrated.
But ICD is something that, okay, it is only disease classification, correct,
Oh,
sir?
yes, yes. For that disease classification,
Yeah.
the treatments and the packages will be there. If this is the
Mm.
disease, if it is a comorbidity like this, then this is the package that you can give. Insurance companies will build the premium on that. The pharmaceutical companies will develop the drugs based on the ICD. The doctors will classify and do certain things based on ICD. ICD is one of the cornerstones.
Mm.
We are interested in how the fever is different in Ayurveda and allopathy. We really don't know. For us, Ayurveda defines it better. Right, we always say how certain things, especially the genomics, is much better than your ordinary proteomics.
But this is ICD, this disease is required only when you are in a model of outcome based,
Yes,
correct?
yes,
So
yes.
especially typically in the healthcare centers like, okay, US and all, where it is more like a outcome rather than premium based.
So mostly it is not premium. They would like to understand how many people are likely to be, because every year, if it is correctly classified according to ICD 10 or 11, they will come to know how much premium has to be charged for next year. So most of the times the reaction happens because the classification of the disease, detection of the disease is not correctly done. Somebody will take for stomach pain, actually he may have a colon cancer, or he may take it for colon cancer, actually it may be stomach pain. The classification is not done correctly. So companies are very much interested in implementing ICD-10, whether it is pharmaceutical company, whether it is doctors, because they can get more diseases, right? For me, any doctor who works in more diseases is not a doctor. So
But
he is a pharmaceutical agent, right? So
but
those
it
are
is
personal
more like,
biases.
I mean, my understanding is that, okay, it is more like, okay, because if a disease is classified under ICD, so I think you can, because most of the insurance or whatever it is paid by the government in the US, that too on the outcome based, which means
Yes.
that, okay, it is not just, okay, I go to the hospital and I have to pay all my premium, or I mean, the entire amount will not be paid by the insurer to the hospital in a one shot. So I think they will have certain time and duration. So based on that, okay, how the patient is getting well with certain
Hmm.
duration, they will give the like, okay, that whatever the hospital charges. Say suppose hospital charges 1 lakh, it will not be given at a one shot. So based on how patient is recovering, that they will give some amounts, percentage of amount.
Hmm. Hmm. No, for me, all those are details for the business. For me, Ayurveda is not recognized in ICD-10 is a problem.
Okay.
It has nothing to do
That's
with anything else.
that's problem is different. I
But
mean,
sir, in India and all, ICD itself is not there in my view.
I don't care. But why you are not propagating Ayurveda in US? Some Maharshi Ayurveda is doing well. Some Sri Ayurveda is doing well. Some XYZ Ayurveda, especially Isha Ayurveda and others are doing well in US. Why the government itself is not ready to do that? Because you don't believe in it. So you establish the science there. Don't try to go with anecdotes. Ayurveda cures that, Ayurveda cures this. Ayurveda cures 80% of chronic diseases.
Correct. But in the
Get that data,
medical,
get that data, hit all the international agencies on the head.
sir, I think the medical world works on the based on the patient trials. As long as somebody proves that, okay, clinical trial, it is positive, so then I think it can be proved.
They are not ready,
But,
no.
but
On
the
one
clinical
side,
trial has to be there.
no, we don't believe in clinical trials because the unlike Western medicine, which believes in a cohort-based disease, Ayurveda believes in one-to-one disease for a single person. Actually, it is the only P4 medicine. It is extremely personalized. So you cannot have clinical outcomes. That's what we are trying to tell. Bring them here rather than sending people out and trying to do something. Bring Americans, bring Europeans to India, cure them and get the detail and push them back. This is what you are supposed to be diagnosed and supposed to be treated and supposed to be cured. It is not happening there. It is happening here. Demonstrate that.
Yeah.
It is happening here.
If it happens, yeah.
It needs backbone, right? It needs courage. It needs belief. So even the Ayurvedic doctors don't have that belief. We have that belief because we are seeing, AI has seen. I have seen what AI can bring out. So we believe, we are for that. So that is another social good project which we are interested in. Personally, I am interested in to push as the envelope as much as possible. Right? There are hundreds of naysayers which says that wow, Ayurveda is actually it is quack. For me, entire Western medicine is a quack. Only surgery is correct. Right? Rest of the things can be cured by Ayurveda itself. I don't need it. But we do not have enough backbone for telling that. Not that allopathy is not bad. I'm not telling that. But worst comes to that, I would like to take that stance. So using allopathy, 90 people will die. Using Ayurveda, only 20 people will die. Let us go for Ayurveda. Because anybody who is stronger is likely to survive. And that is natural law. And Ayurveda is based on natural law. So your Western medicine is not based on natural law. It is based on homeostasis, which is wrong. So we have too many things, but let's keep that aside. These are the personal social good projects which we want people to involve and see that experiments can be done, AI can be implemented, because we cannot change the Western doctors or the allopathic doctors and Ayurvedic doctors. But we can change AI. AI depends only on data. When we said include all these things, AI wants data and that data can be used for including Ayurveda in ICD-11. It's possible, we can do that, but our interest is not that as of now. Our interest is, can Ayurveda detect health? Can it become a preventive medicine, predictive medicine, personalized medicine and participative medicine? So which is called as a P4 medicine. Currently there is no mention of food and sleep in Western medicine. How much a person has to sleep? Somebody will say 8 hours, 10 hours and all. Ayurveda clearly mentions all those things. Can we personalize it is one of the things we are looking at. Can we personalize it? So Ayurveda is a personalized medicine. Can you work on that? These are some of the things which we are looking at. There also it is image analysis, it is text analysis, and it is voice analysis. So it is voice analysis. We are going for convergent AI. Multiple AI technologies will be brought into picture to work as a single solution. One of the experiments that we are doing now is, can a doctor speak to patient? There is a method called as Dasavida Pariksha, where 10 different categories of questions will be asked and the diagnosis will be done based on how is your Kapha, Pitta and Vata. Based on that, the Prakriti, the medicines will be prescribed. They don't have diseases, they will have the abnormality of the Prakriti, and based on that they would like to give the medicine, which is called as constitutional medicine. So can doctor speak to patient? Can doctor understand what patient is answering? And can the doctor be video based? And can that video base be no human but is a computer generated image using GANs? That is the long term project that we are looking at. Can I use a GAN image that is generated as a video, speak to patient, convince the patient in a very mellifluous voice and ask right questions and understand what the patient is telling and give the diagnosis, or in fact we do not want to call diagnosis because they can take us to court. We call it a screening. Can it give a screening? Then it can be used for anything else, and that is one of the project which we are very much interested in. Apart from that, can I look at your face and detect what is your prakriti, how much kapha, how much vata, and how much picha is for you, right? Whether people like it or not, when there are boils in the tongue, we call it as ushna. It is pitta, and we say that eat some coolants, right? Drink some tender coconut. Actually, it goes off. You can check that without taking B complex and all Western medicine. You can test on smaller things, which you can take risk. It works. It is working, and we would like to see that. Can we diagnose that? Just the moment I see the boils on your tongue, I know that your pitta is very high. It is not balanced. Now, can I detect that from face also? Can I correlate that? And the moment you show me your face, can I tell you today your pitta is this, your mental states will be like this, and better you meditate or breathe or take cold water bath or go for hot water bath, go for walking. Can I recommend something so that I will keep you balanced? We need data for this. These are all ideas. These are all currently every text says, but no evidence. We would like to collect, because current evidence state is about 400. We would like to take 400 samples, test that, how it is working, how it is not working, give it back. That is the project that we are trying to do. Go ahead and if possible participate in these type of projects. Yeah. Okay. Let us come back.
You have very good knowledge in Ayurveda and naturopathy.
So when you start reading, you will also get it. What is there? All my knowledge is
I have
bookish.
already read a naturopath, and my sister is an Ayurvedic doctor, so I know. I just listening to you.
Probably yeah, they may have experience. I'm not experienced. Nobody comes to me for medicine.
No. You were like telling the truth. I was just listening.
Yes, yeah, I will teach you that. You can speak
And
truth.
even I am interested to participate in one of the project, but the thing is like I'm not sure whether I will be able to find the time out of the office and this MTech. So that is the reason you
That
told.
I will tell the truth.
Mhm.
First is God, next is me, next is everything. I will make time if I want it for me. Right? That's okay. I will leave it to you because everybody has different opinions about how they would like to live, their priorities and others. My priority is myself first. Okay. Good. Let's go back. Let's go back and we would like to find this. Now let us find this with what we call as the pivot table. Let us get the pivot table. We will take pandas pivot table. So we have this, this, blah, 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 blah. So now let us take this. We will build the confusion matrix and we will show this. So confusion matrix is basically to get is PD pivot table index. There is no label. There is Y. So I will detect Y. Predicted aggregate function is prediction, not predicted. So this will be prediction. So this will be prediction. Predicted do not exist. Where is predicted? Prediction. So prediction, right? Now I got it, right? So 5 by 5. Actually predicted is prediction is 0 out of 0 predicted class 0. All the 5 are correctly classified and predicted as 1. All the 5 are correctly classified. Now, but I am getting nan which is to be replaced with 0, right? Fill number is the next one. We can add that and whatever is the filling value or a missing value manipulation, how we would like to do, we would like to do that with 0, right? So my 0 value is added here. Now I can see oh no. So let me change this. I will use this only because already we have built everything here. Okay, now we'll add fill value. Is equal to 0. Right, now we got this. This exactly is one thing that we are looking at, right? How do we get the confusion matrix? Once we get the confusion matrix, we would like to look at accuracy. What is accuracy? Accuracy is simply how many true positives, how many true negatives divided by total. how many correctly classified divided by how many recalled, right? Or total, actually need not have to be recalled, it will be total. So I will take TP plus FP divided by total is what is called as accuracy. Accuracy of a model is very important. It tells me how good the model is, right? Now in this case, what is the accuracy? What is the accuracy in this case?
100%.
100% accurate, right? It is 100% accurate. Now let us get this, right? Now we are getting this, right? My confusion matrix is given. My confusion matrix, let us say that my true positive, right, is this. My true positive is equal to, or my true positive is this, where I am predicting it as 1, actually it is 1, right? My true positive will be confusion matrix, my value will be uh, so confusion matrix, this will be 5 plus 5 by 10, right? I had to convert this into CM is equal to confusion matrix confusion matrix dot values, right? Now I can print my CM. You can see I can access all of them as array. So now my TP, right, my true positive is equal to CM, right, 1, right, CM 1, because this is the first array, right, first list, and 1, this is my, so now look at the true positive. So this is my true positive, right? My true positive is 5. I will do the same thing with my false positive, right? My FP is equal to CM 0 1, right? My true negative is this, this is my true negative, my, sorry, this is 1 1, 1 0, so this is 1, this is 0, this is 0. My true negative is equal to CM 0 dot 0, 0 dot 0, right? Next is my false negative is equal to CM 0 and 1. So now I can print my TPFP and all those things. I can print, let us say, print TP F, right, comma FP percentage F, comma TN percentage F, comma Fn percentage F is equal to XYZ and things like that. This will be my TP, FP, TN and Fn. So I will print this, right? My TP is 5, my FP is 0, my TN is 5, my Fn is 0. Now my accuracy is defined as TP plus TN divided by total TP plus FP plus TN plus Fn, right, into 100%. This is my accuracy. So now I would like to give accuracy, print accuracy is equal to accuracy. This is my accuracy. This is my 100% accuracy, right? We can change this a little bit. right? We can change this data a little bit. Now let us say that I would like to make yi, right? I'm taking this, let me put this. So you do this, then we will make some changes and we will see how we solve this problem. Are you getting what exactly we are trying to measure? For any classification problem, we will measure accuracy and confusion matrix. Why confusion matrix? Sometimes we go with the recall and precision or the FP versus TP also, right? For lesser FP false positives, we would like to get higher TP, which is called as the ROC, right? Receiver operating characteristics curve. So it was used earlier in sonars, radars and things like that, where they were sending some signals, and if the signal is back, actually it can hit a bird and come back, it can hit a metal structure and come back, or it can hit a plane and come back. How much of the receiver operating characteristic is looking like a plane? Only that has to be taken here. So for that we had to send certain frequency only, and that's how it came from the war zone through electronics to data mining in artificial intelligence. So ROC came through medicine, ROC came through war, but apparently it is used by AI people to understand what is the ROC. Why we had to go for ROC? Now let us take an example. It's a fraud analysis case. Only 0.1% is fraud. 99.9% is not fraud. If we don't use any model, how many of them are genuine? Out of 10,000 records, how many of them do you feel are genuine? It is only 0.1% fraud. 10,000 people, 0.1%. Only 10 are fraud. 9,990 are not fraud. What your model says? If your model says 9,990 are not fraud, or simply say 10,000 are not fraud, what is the accuracy of the model? You getting the point? Yeah, 99.9%, right?
Yeah, yeah.
It is 99.9% accurate. Do you take that model? Are you getting the problem? Now I have my confusion matrix is something like this, right? So it can be, you predict fraud or genuine. Actually it is fraud or genuine. You predict all 10K are genuine, right? Only 10 are fraud, right? 9,990 are genuine. So you no frauds are there, no frauds are there, right? How much accurate my model is? My model is accurate by, this is true negative. This is true negative. Are you interested in genuine cases or are you interested in fraud cases? If you are using AI, right, are you interested in genuine cases or fraud cases?
Genuine cases, sir.
Genuine cases. How many genuine cases were here?
0.
0. And these type of models are called as stupid models. Right? We should not use these type of models. So what is the moral of the story? Increase the true positives. If the true positive is not detected, it is not a good model. Whether it detects false, true negative or not doesn't matter. Is it detecting true positive? Very, very important. It is detecting, it is not detecting true positives, it is not good. Now let's say model accuracy is only 75%, right? But it detects 6 frauds. Is this a good model?
No, sir.
So 75% accurate, but it detects 6 out of 10. 6 frauds out of 10 are detected.
That is good.
Better than the previous one.
Yeah.
Right? It is better than the previous one, right? But accuracy is not good. This is 99.9 accurate. This is only 75% accurate. This is what you have to keep in mind whenever you try to build any predictive models using AI. Lot of people will tell me AI is new. No. 40 years back, there was a company called as the American Heuristics. They were using a neural network called as Falcon 40 years back in 1980, 1982, 1976 to 1982. They have built the first neural network to classify whether the credit card transaction was a fraud or not. It is not new. AI is not new. Right. So those are the applications where we are looking at. Fraud basically is a deviation which has no pattern. Can I predict that? That is the toughest problem we have. Fraud modeling, anomaly detections, these are the real problems. Right? Who will respond, who will not respond is very easy problem to solve because we have templates. Amazon gives pre-built model. You just push the data, within half an hour the answer is out. You don't need to wait for anything. Right? But deviation detection, anomaly detection, fraud detection are still the problems which need attention. So you can look at such kind of things. In fact, yeah.
I'm sorry, you can finish your word,
Please.
you can ask the question.
Sorry.
No, you can finish it, sir, then I'll ask my question.
No. Go ahead, please.
No, I was asking again, it will looks like a theoretical question. If someone says like your positive rate, okay, so find out the positive rate because you are talking about true positive and false positive. So someone, if a problem comes like find out the positive rate when the false acceptance rate is 10%. So how to interpret that?
Sorry,
False
come again.
acceptance rate is 10%. So it has been asked, right? You find out the true positive rate, okay? And I've given with the criteria condition false acceptance rate is 10%. So how to
Okay.
interpret that?
So basically, you can accept only your true positive rate within the decile, or let us say that you have 100 people, but you take 10 people. Out of that, you can accept only one as the false positive. Other 9 should be true positives. You are getting the idea. You take 100.
Okay.
10% false positive acceptance rate is out of 100 predictions you are making, 90 should be correct, true positives. Only 10 can be false positives.
Mm-hmm. But then
Right.
apply the how to apply. Suppose you have a model, you are building a model, and it is in that model you are getting certain false positive and true positive rate. Okay, and so then this condition is given. So how do I
It is
put that
very
in the
dangerous. It is very dangerous. Actually, such kind of conditions are called as arbitrary, whimsical conditions given by somebody who do not want you to enter the building. So if somebody gives that, they have to give me the baseline. What is baseline? You are bringing an AI model. You have to use that here. Currently, I am using some domain rule. Let us say medical rule here to detect the false positive rate of this test is only 10%. And this is the rule. I have conducted 100 experiments, and based on that, right, I found that 90% true positives is available, 10% false positives is available in my system. Now, when you build a model, if your model is less than 10%, you can go and beat them. Your current system is not good. My system is capable of giving 9% false positives, 91% true positives for the selected sample. So I am 1% better than your current system, and I am a software, not hardware. I am not domain. If the domain leaves, you don't have anybody to interpret that. AI, whether domain is there or not, forever as long as I am alive, I can do that. So cost wise and trust wise, I am more important. So I am giving 91%. So without context, don't discuss anything. So if they are giving the context as 10% positive rate is with me, then your positivity rate or your false positivity rate should be less than 10 when you go with your solution. If it is more than 10, it makes no fly at all, right? Already they have a solution which is giving 10% false positives. So if you say my system is 99% accurate, but for the sample you had given, it gives me 12% false positive rate. Nobody will take that. On the other hand, you say that I am 99%, 99.9% accurate. On the 100 samples you had given, I am 99% correct. It flies like anything. That's the interpretation. You don't get caught into only one sentence given to you. You don't know the standards. Very dangerous. Okay. Yeah. Okay. Any other questions? Let us look at any other questions if you have. Problem, no problem. Okay, let me share this so that you can have it. Let me change this as ELM classification. ELMC. It is ELMC. Okay. So I will download my Python notebook. Let me send you. I will reply it to all. Okay. Attach something like this.
I have seen in AI and machine learning, actually you have to be very specific. Like we have ROC, rank order clustering one side. If someone just say ROC, people will get confused. Then we have rank order clustering, and today we are talking about rate of classification. So we have to be
Yes.
very specific.
Hey, it takes time. You get the vocabulary, you can start speaking. Right. First 3 months to 6 months, your job should be to get the vocabulary of the domain you are in. Then you start speaking anything. Right. If the other guy agrees and he pays, why should you bother? If he asks, then you have to explain. Right. Actually, if he is not giving money and if he is not asking, that is the dangerous sign. It means that something is going above his head. So we have to go down to his level and see why he is not paying me what I want. So that has to be understood. Learn the vocabulary and learn how layman thinks, and you must connect both of them.
Yeah. I think what I'm feeling, my feeling, this I'm telling, this is a new thing for me. My feeling is that the best way to learn is do everything from scratch, and don't use any library, and try to do on your own and see.
Oh, that's correct.
That's
That's as far as if you want to implement the algorithms. If you are a
yeah,
coder, but if you are
yeah,
a
yeah,
solution provider, it may not be needed.
maybe, yeah. I mean, yes,
Yeah,
solution.
only scripting may be needed. It depends, depending on where you get into now. After your MTech, if you are getting into product development from scratch, yes, your knowledge of from scratch is very essential. But for all the other purposes also, now we saw one problem where I am trying to find the inverse of a vector, which is not possible, right? If you knew the basics in linear algebra like this, it could have been very easy for you to understand, okay, what is not happening when you get into deep neural network. So all of them will depend on NumPy or similar kind of libraries. So once you know the principles of matrices, it becomes easy for you to run any library and understand what is going behind the hood. Yeah, I sent you the C. Work on C and C. Do you have any problem with that? Then we will go for some decompositions, and maybe after decompositions, let us look at some of your presentations. Some of you who have presented last time, if you have improved it, let us look at it. Others who are not done anything, let us take a look at it. Okay, you're done, not done, how is it?
Sir, I have improved my presentation, so if you would like, I can share.
We'll break for some 10-15
Okay,
minutes. When we are
fine, fine.
back, we will look at that. Others, how about others? Others are working on it?
Sir,
Not
I am
yet.
working on it. I may need some more time. I'm just started the implementation. I have the problem statement clear. So implementation, I will do it in this week, sir.
No,
Probably
but I would
next.
like to listen to everyone. What is their thought process? What is that they are doing? Because we are recording it. That should be used for your assessment.
Sir, in my case, I got the data So I'm analyzing it how to uh, basically find that rate of classification, and if that can be you know uh, realized through some plot to
Huh.
understand. So that's what I'm right now in position. So we'll take
That's okay. We'll see that. We will see whatever is the current status. We will see that. Based on that, we will take a call.
yeah, yeah.
Okay. Okay. We'll connect again by 3:45.
Okay, sir.
Yeah.
340. So you're muted.
No, I was not speaking. I'm just waiting for people to come, so we'll see.
Okay.
Okay. Okay. Now let's get on to some simple decompositions, why we need decompositions and how we do it. Let us look at them. Right. The actual applications will be taken up maybe in the text analysis, maybe in the machine learning. We will see what are the different types of decompositions we can do. But before that, let's understand what exactly is a decomposition. Now let us take this. We'll remove this. Now let us look at this example, which says that 2x 3y is equal to 5, right? 3x plus 2y or 3x plus 3y equal to 6. I am taking a set of simultaneous equations. You can ask what is this simultaneous equation, what can be done. Now let us take that x and y are products that are to be developed. A manufacturing unit, a house is capable of making papads and making maybe some kind of crackers or possibly some kind of roti, whatever it is you call anything. Product X and product Y it can make. But based on the limitations, this can be people limitation, this can be machine limitation. You can make 2x plus 3y which should be less than 5 or 3x plus 3y which should be less than 6. This is a practical application of this simultaneous linear equation. Though we studied this in our 8th standard or 10th standard, whatever it is, practically nobody will teach you unless you study operation research. How exactly this will be applied in product mix, right? In all other areas, it will not be taught. But generally, simultaneous linear equation is one part of linear algebra. And this part is called as decomposition. We will see what is decomposition. Now, if you take this 2x plus 3y, 3x plus 3y is equal to 6. Now, I would like to rewrite this equation. I will take it as 2x plus 3y is equal to 5, right? And I would like to deduct this. When I deduct this, this becomes minus 3x, right? Minus 3y which is equal to 6 or minus 6. Now I would like to add it. When I add it, what I get is minus x is equal to minus 1 or x is equal to 1. Now if x is equal to 1, I have 2x plus 3y is equal to 6, right? Substituting x, this becomes 2 into 1.
Sir, 2x plus 3y is equal to 5.
2x plus 3y is equal to 5. Okay, this is equal to 5. 2 into 1 plus 3 into y is equal to 5. So this is the solution. Now we are changing this. This becomes 2 plus 3y. This is equal to 5. My 3y will become 5 minus 2. So my 3y is equal to 3. My y is equal to 3 or 3 by 3 which is equal to 1. So finally my solution is x is equal to 1 and y is equal to 1 is what is possible here. If this is the thing that is the limiting factor, so this can be solved when x is equal to 1 and y is equal to 1. So these type of things is called as decompositions. We are decomposing these two into the constituent values where we can find the value of x and y. Now if we look at what we have done is we have taken x and y, right? I have taken x1, y1, right? And x2, y2 I have taken this. What I have derived is I have made it as x1, y1, right? And then 0, y1 or y2, right? Now x1, y1 which is z1 is already there, which is my value, right? And my z2 is there, right? My z2 is there. Using this I can easily find what is y2 or actually what is y, right? Simply it is y2, y3, xyz, something like that. It is x and y. The value of y now is z2. Whatever is the value of z2, that will be the value of y. And replace this here and you can compute the entire thing. And this is what we call as triangular decomposition. This basically is upper triangle. So you can see upper triangle. So same thing can be done for lower triangle, doesn't matter, right? You can do for lower triangle also. And this work now we are done so simply, right? This has been taught and we thought that okay, it's very easy, this is algebra. Yeah, this is algebra. When we try to extend this to thousands of variables, right, you can really see the practical application. This in fact we don't do for thousands of variables because our task is to understand how LA libraries are implemented, how LA can be used. We just understand conceptually if this case can be extended, because I have extended to 2 variable 2 equation case. This can be extended to 10 variable 10 equations, 1000 variable 1000 equation case, doesn't matter. So idea is that this is decomposition. There are plenty of decompositions which we had to discuss, right? Let us take up one by one. There are few decompositions which are meant for doing certain things and certain decompositions which are meant for dimensionality reduction or new variable creation and things like that. Let us look at each of them, right? The first of this is called as LR decomposition, right? So it basically says that lower and upper triangle decomposition, right? So let us see how exactly we can do the decomposition. Let me start new one as decompositions. Tack, tack, tack. So now when I say that there is a matrix that is given to me and I would like to decompose this into lower matrix dot upper matrix, it means that if I use these two, I must get this matrix. You're getting the idea, right? LU factorization or LU decomposition. Factorization or decomposition. So I would like to decompose this based on given lower triangle and corresponding upper triangle. I can find UA very easily, but actually this is only the theoretical property. We are not interested in this property. We are interested in finding U or L so that I can solve my equations. That actually is my intention. So if you look at this, let us take up one matrix, right? Now let us take up so LU, right? This is one of the expectations. Now I don't run this, right? I will add the next line. Right now in the next line, let me say that I would like to create an array. For that I will create matrices. Matrix, for this I had to import from numpy, right? Import array, right? Also I had to import another library called as scipy, right? So from scipy there is what is called as, in fact you can import all of them. First let us import this and see, okay, now we had worked with this. Now let us import scipy. import SciPy. So you can import SciPy. Running forever. Okay. Now let us look at what is inside SciPy. So that's a better way of understanding what is there. So if you look at it, there are a lot of things in SciPy. Some of them we are interested in is decomposition. So one of the decomposition that is likely to happen is LU decomposition. So if you come down, it talks about LU decomposition. Let us look at where is it. So my LU decomposition. So my LU decomposition. Can you find somewhere? Should be somewhere in. Let me check where exactly is LU decomposition. SciPy LU decomposition. It may be hidden inside because it was not visible. So it is linear algorithms LU, right? I had to take this. This is one type of, okay. So I have all linear algorithms. Now let me get into SciPy, import SciPy, import SciPy linear algorithms. So what are the linear algorithms that are available for me? Now it tells me. So there is no linear algorithm. SciPy linear algorithm. LU. Okay, it is there. It is there. Okay, so why it is not showing me? So we'll take this SciPy linear algorithms. Now instead of import SciPy, I would like to import SciPy linear algorithm, right? Now I would like to call back, right? So when we do this, basically the idea is there must be, actually even though we are telling it is PLU, right? What happens is it will return something like P, L and U. So when you decompose, when you call this module called as lower and upper decomposition, it returns one P matrix, one L matrix and one U matrix, right? Now let us create our arrays. Now we have created this, and from this let's go for creating the array. Now I would like to create some array. Let me take this, my A is equal to 1 2 3 1 comma 2 comma 3. Then I would like to go for 4 comma 5 comma 6. Simply I am putting something. If it gives error we will see, rather than searching for the best, right? 7 comma 8 comma 9, 7 comma 8 comma 9. So this is my array. Now we would like to print array, print A, right? It is nothing but a matrix. It is printed, right? Now I have my array. I would like to get my PLU. So as you know that whenever I call this function, it returns P, it returns A, L and it returns U. So it means that P is the planning matrix, L is the lower triangular matrix, U is the upper triangular matrix. So let us take this P comma L comma U because it can return multiple values, right? And I can assign multiple values in Python. So what you would like to do is, I would like to use LU and send A, right? It has done the decomposition. Now let us look at what P is. P is a matrix, right, which contains these values. This is how it has been decomposed. Now we would like to go for L. You can see how L looks like. Now if you look at it, this becomes lower triangular matrix. So only first value is there, and if there is a z value, I can just equate this. 1x becomes z value. So my x is solved. Once my x is solved, here my x, I will replace x, y can be solved. I will replace x, y, z can be solved. You are getting the idea. So this is decomposed. Similarly, let us see whether we have upper triangular matrix. Triangular matrix. Right. So now we can see upper triangular matrix gives me, okay, this is 0, this is 1 plus 1, this is 1 plus 1 plus 1, right? Now we would like to test whether I can reconstruct it. Reconstruction. So because according to this formula, it was supposed to be PLU. If I go for P dot L dot U, I must get AR, right? A reconstructed is equal to P dot L, right, dot U, right? Now print AR, right, then print A. Now look at this. No, it's matrixified. Actually, it is converted into float. My AR is 1, 2, 3, 4, 5, 6, 7, 8, 9. My original matrix was 1, 2, 3, 4, 5, 6, 7, 8, 9. So it means that whenever you try to decompose and recompose, reconstruct, you will get the same thing. When you decompose it, you will get the upper and lower triangular matrix, and when you compare that with the planning matrix, so when you compare that with the dot, right, or when you combine that with the dot, you will get the original matrix. Can you try this? Can you try the matrix decomposition? It is simple LU with SciPy, right? We will not get into understanding properties and all. One of the beautiful things about programming is it will make us naked. So immediately it throws an error. Buzz, you don't know this. Unlike the calculator where after doing all those things I will be told there is some error. But programming tells me that you have done some blunders here. It will not work. So it throws the error. Okay. So just check this. Can you work on the LU matrix? Then we will go for the QR matrix. So most of the times the LU is used for square matrix, the QR will be used for a rectangular matrix. Yeah, we will see. Done.
So from SciPy, which library you inputted?
Linear algorithms, LeanAlg,
Yeah, yeah, okay.
LeanAlg library, linear algorithms library. Okay, let us go for the next one. So once we are done with LU, let us take up some example in basically a QR goes with the left and right, not lower and upper. So QR decomposition. Unlike intermediate matrix like P, A is equal to QR is actually what happens. If you want to reconstruct, you can just reconstruct with Q and R, right? This is what we are doing, Q and R. So, okay. Now let's execute this. Let us see how this works, what can be done. So I will take my values. Let us take some value. So let us take A is equal to 1 2, because I told it will be for rectangular matrix. We can take 3 4 right? Then 5 6 5 comma 6, then okay, let's have only 3. It is a rectangular matrix. Let me put a comma here. So we have A here. Now I would like to get my decompositions, right? For that I would like to use from scipy dot leanalg, right, import QR, right? I would like to import QR decomposition, right? I got it. Now I would like to get my Q, and I would like to get my R is equal to QR of A. So I am getting QR of A, right? Now let us print Q. Q will be printed. Now you can see it has nothing to do with lower and upper triangles, right? So now you can see the wonder. So I had 2 by 3 matrix, but I got 3 by 3 matrix, right? Now what do you expect R to be? 3 by 3 or 2 by 3 or 3 by 2?
3 by 3.
It will be 3 by 2, because if you want to reconstruct, you will be having 3 by 2. Now let us print R. Can you see? It is 3 by 2, 3 rows by 2 columns, isn't it? Now let us reconstruct AR. Reconstruct AR, right? My AR is equal to Q dot R, right? It is been done. Now let us print A, right? Oh, A. Okay. Now let us print AR. Let us print A and let us print AR. Now can you see my original matrix is 1 2 3 4 5 6. My reconstructed matrix is 1 2 3 4 5 6. So it means that the reconstruction or decomposition should work together. When you decompose something but you cannot reconstruct, somewhere something is wrong in the decomposition. The moment you decompose something, you can recompose it. Yeah, can you work with this QR? Construction and reconstruction, decomposition and reconstruction. Yeah.
So what does the Q stand for?
Sorry.
What does the Q stands for here?
Q basically is one function which is decomposed and minimized. Basically, I would like to find the essence of this A, right, which can be multiplied by another. In fact, you can look at the theoretical definition of what Q or decomposition is.
Okay.
So for us, the way we try to remember is what is to be used for what, and what are the conditions under which I should not be doing, right? So now if you look at it, normally it will be done for rectangular matrix, right? So there are multiple ways. What Q means, Q, nothing is been mentioned. It's just Q and R.
Is an orthogonal matrix.
It's an orthogonal matrix. Every more or less it's a rectangular orthogonal matrix.
R is an upper triangular matrix.
Where is it given? Somewhere else, not in wiki. Is it there?
No, scroll up. Little down. Yeah, down. There you go. The first line after A equal to QR.
Ah,
An orthogonal matrix. That means QT equal to Q inverse and R is an upper triangular matrix.
upper triangular matrix. Not much.
A
It
is
is not.
invertible. A is invertible.
Invertible means from QR you can get A, from A you can get QR. That property we already saw. But what exactly R means, right? Upper triangular matrix can be U. Why it should be R? Some history will be there, which even I never question. Why should we use it? Right? History and all is good. Nothing wrong with that because it repeats. So what is the meaning of QR?
By any chance, it is there in the engineering course? This Q
Absolutely, this is there in your numerical piece.
Okay, okay, okay.
So Cholsky decomposition, QR decomposition, LU decomposition, Newton-Raphson method, Runge-Kutta method. There are plenty of
Oh,
methods.
okay, okay. Rangi-Kutta we know.
Yes.
Numerical analysis.
Yes,
Okay.
numerical analysis.
Okay.
All branches of engineering should know that. Otherwise, they cannot write. They cannot solve linear equations.
Actually, yeah, correct.
Yeah, this is numerical analysis.
Okay, okay. Got it, sir.
Yeah,
No,
yeah.
I mean, we know Rangi-Kutta, but somehow this decomposition, I don't remember.
Runge-Kutta is for solving an equation, not
Okay.
simultaneous equations. So decompositions is for solving multiple equations. Runge-Kutta, if you want to find what is the value of x when x square plus 2x plus 3 is equal to 0, right?
Yeah.
Instead of going through minus b plus or minus blah blah and things like that, we will use Runge-Kutta method.
Okay. Yes, sir. Yes, sir.
So there are plenty of such kind of methods. So pivoting, stepwise pivoting, no, I am not finding what is the meaning of it, right? But another important one which we have to learn is basically the singular value decomposition,
Sir,
right?
yeah.
Yes.
No, I just saw LU decomposition. Before that, we are discussing LU.
Yeah. Yeah. Okay. LU decomposition.
No. In that Wikipedia, I just saw a link for LU decomposition.
Oh, okay. The third important decomposition that we have to study is called as the singular value decomposition, right? Now, some of you might have studied this well, right? Let me show you this. So this is called as the resolution of forces. Now let us say that I have a orthogonal system where it is x axis and y axis. This is my y axis and this is my x axis, right? Now I have multiple forces acting from different positions. So this is F1 which is at F1, it is at theta 1. So this is my theta 1. Now I have F2 similarly with theta 2, maybe F3 with theta 3, like that I may have different forces. Do you think all these forces are independent forces? Like Indian political parties, every state will have 10 political parties and they would like to attend to their political parties, or all of that can be decomposed into two national parties. We have done this, right, in statics, right? In mechanics statics, we used to do this. When you try to apply the force in multiple directions, all the forces will have the effect in vertical or horizontal direction, not in any other way. If it is moving in the horizontal direction, it is the force in this direction which is moving it. If it is moving up, this force is not there. What do you want? All these forces, if you want to maximize the lift, all these forces should be aligned in this fashion. If you want to move it in this way, all these forces should be moved in this direction. If they are not, part of this will be vertical, part of this will be horizontal. And now we would like to call it as F1 and F2. Now can we calculate F1 and F2? Can we calculate F1 and F2? We can calculate F1 and F2. It says that, so it is nothing but all F1s, all F1 is nothing but or sine theta is equal to F1 into sine x1, right? Sine x1 plus F2 into sine x2 or sine x2 plus x3 into sine x3.
I think instead of F1, it should be F. Like, no, sir, FX.
Yes. Let me change that. It is F3. So instead of this, it will be F. Now we can rewrite the same thing as F2, right? This is nothing but F1 into cos x into cos x1 plus f2 into cos x2 plus f3 into cos x3. So we have this. So now we can see all of these forces have been reduced to only two forces, isn't it? I can have 100 forces, still I will be reducing it to two forces where the effect of each of the force on vertical or horizontal direction can be seen, or I can see effect of this force on this direction, effect of this force on this direction. In whatever angle I want to see, I can reduce that, I can decompose that. Such kind of compositions is called as singular value decompositions. First we will have in two directions, and in any direction you want you can have that. The way we try to decompose that is like this: M, U, E and V, right? So we will, you can read through all of this. In fact, I will not get into the details of all of this because most of the time we will be using it, not discussing what it means and all those things, which will be discussed during your text analytics sessions, right? How exactly each V11, V12, V21 and all those things will represent words, and using those words how can you reduce the number of words that is required to represent a particular document. Can you summarize the document using SVD? You can do that. You can do summarization using SVD, right? But let's not get into that. Let us understand how SVD works, how to call SVD, and some examples. We will not get too much into SVD and all those details. Let us get on to simple ones. Okay, so now going forward. Ta, 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 ta. So now let us look at this, right? I would like to bring my algorithm, right? So as we know, my singular value decomposition SVD algorithm goes with A is equal to some kind of MUV or UE and V. So this is the formula, right? Now let us look at how exactly we can execute this. Let us build an array, right? We will take A is equal to 1 comma 2, 3 comma 4, 5 comma 6. Let us have this as our array. Now we have our array, and I would like to bring what is U, right? What is E and what is V, right? So all of this you can call by any other name. I would like to bring SVD, SVD of A. Sometimes this gives error. The reason is I have not imported, right? Now let me import it here itself. I will import this as from scipy dot linear algorithms import SVD. So when we do this, so it gives me SVD. Now I can print U, right? So U is a bigger matrix. Now I can print B, E and V. Now I can print E, right? This is what we are interested in. This can reduce, this can, I can use this and I can build rest of the things, right? I am interested in E, it has been reduced, right? So first it was expanded, then it is reduced, then it is brought to some normal shape. My interest is this, my value is become singular value now, one column. My two columns has become one column, and this will be used for reducing the number of variables. So we can see that later. I will not touch upon that now because I just wanted to see what SVD looks like, how we build that. Subsequently, when we take up text analytics, we will see how we can use SVD to build a compression summarization algorithm. We can compress a document and summarize it using these words. So we would like to see what is this word and how exactly I can use only these two words to represent the four words I got. We will see that. But now our idea is there a possibility? Is it reversible? Right? if I can recreate it, now let us see that my AR is equal to my U dot E dot B, right. So it says that you cannot do that. So it means that singular value decomposition is not recomposable. I cannot recompose. So that you have to keep in mind. I reduce the dimensions, but if I want to create back the data again, it becomes very difficult. I cannot do that. Okay. So most of the time singular value decomposition is used for dimensionality reduction. The other two will be used for optimization. When we want to optimize something, it can be product mix optimization, it can be number of workers that are to be optimized, whatever it is, right? We will use decomposition. Any questions here? Work on this, right? You can just look at it.
Sir,
right?
what is eigenvalues?
So eigenvalue basically is a special case where sometimes what happens is, you might have heard about Zwicky. There was a scientist called as Zwicky. You can look at him. He says that there are two type of stupids. So one is general stupid, another is spherical stupid. General stupid is they are stupid only in certain areas. The spherical stupids are stupid in every area. Right, he used to call people whom he don't like as spherical stupids, right. So if we take that joke, any matrix can have what is called as its constituent or original value, which is called as the native talent of a person or the native representation of the matrix. You multiply by any other number the eigenface or the eigenvector. Eigenvector is nothing but the diagonal vector which will be having some number. You multiply that with any other matrix which is decomposed of eigen decomposition, you can reconstruct that with eigenvector. Most of the times eigenvector will be used to identify what is the constituent matrix. So you can look at that. Eigen decomposition, eigenvector. So eigenvector is something which is a singular vector or a diagonal vector which tells us something about the property of a matrix which is unchanging, it is not changing, right. So when we get this too much, less examples, too much of theory. Okay. This becomes my eigenvector 2 minus lambda 2 minus lambda. When I try to do all those things, when I convert that, my eigenvector is minus 1 for this. This was my original vector, right. My eigenvector is minus 1, right. With all other things same, whatever the diagonal, the number which is same, this vector is called as the eigenvector. And the matrix which is composed of this is eigenmatrix, right. Generally this will be used in image processing when we would like to find eigenfaces, the faces which are similar to each other. Anything that has a same eigenvalue is most likely to be a eigenface. So that is what we try to. It is more similar to SVD, but eigenvector we rarely use in machine learning. Normally we try to use in the image processing, though it is used in some cases, not widely. SVD is widely used one. Okay, so any other question? Okay. So just go through all of this, and possibly next week we try to have, I will also go through the videos and I will try to formulate some kind of quiz based on this, whatever the discussions we had, right, mostly on the discussions we had, nothing outside that. It will be thought provoking. If we can get it in Google, copy it and do it, because it will be an open book test kind of thing. And even the exam is based on whatever we have covered so far, right. We want you to write the code for a given matrix. Each of you may get a different matrix. We want you to develop certain things, right. either develop an algorithm and work on some data and demonstrate that you can classify that, or you can predict, or you can do something. We want to see the results, right? So please work on that, and let us see how it goes. Okay. Now let's move on to your presentation. Some of you, if you can present, let us see how it goes. Over to you, team.
Sir, one more, just one last thing, sir.
Yeah, go ahead.
In the, I mean, I'm just referring the syllabus. Some projects are there, sir. It is mentioned about some projects about customer segmentation, dimension reduction, top modeling assignments, boiler efficiency prediction, credit risk model, etc. Some projects are there. Anything we can take up, sir? Basic idea, implementation, application community. Okay, sir. That is, yeah, rank order clustering. We have got one actually. So anything, any projects or anything we can take up?
Oh, you can take it up
So
now. I mean,
no, not now, sir. I mean, something. I mean, we'll get some problem or anything that we can try or something like that with your
oh,
guidance.
you can always try, but there is no need for you to use this algorithms what we are trying, right? You can try with scikit-learn or better libraries. If you are taking this as the algorithm that you would like to implement, then go deeper.
Mhm. So actually, it is talking about the algorithms like for principal component analysis.
Hmm.
There are some projects it is mentioned in the syllabus: customer segmentation, dimension reduction, and top modeling
Eh,
assignment. Yeah.
Yes, you can take up those projects. In fact, earlier we did those projects, but it
Okay.
was taking more time.
Okay.
So you can listen to the previous versions where we had done those projects, or you can implement with the kind of project what we had done. For example, if you look at the segmentation, let us take k-means. Let me open up k-means, and we would like to look at k-means. Open a notebook. K-means numpy. Right. I think have we done this? Yes, we have done this. Right, we found this. Now look at this. So we will work on one of the projects which is mentioned there, customer segmentation. You can just take whatever the data we had given as customer segmentation, because for you it makes no difference. As an algorithm development specialist, right? What is not there? N is not written. Oh, okay. So now I can visualize I can do something. I found the centroids, right? I am trying to do this, right? We can start and stop, right? We don't need this. We built all others, right? Now we built our file upload. For example, we did this ABC class,
Yeah.
right? Now let us look at this ABC class, right? So this is inventory segmentation. You can do the same segmentation with, so ABC class. Let us look at where is this ABC class. So this is my ABC class. I uploaded. Now I got all of them, right? Now I can see what data is there, right? I can look at df dot head, right? We can look at the data, right? So SKU, average unit cost, annual dollar usage, critical factor, lead time, all are numeric, because k-means and most of the LA algorithms can work with only numeric, right? It will not work with objects or symbols. So you have to go for another project with the symbol manipulation in SciPy, not linear algebra, right? I will take only these four variables now, right? 1, 2, 3, 4, and I will take the values. That becomes my data. Now my k-means is given like this, and I would like to see the centroids. Right now you can see 4.6, 4.2, and 3.8. So the first variable average unit cost doesn't make any sense, so it is not having any effect, right? Similarly, see 4.9, which is 5, 1.5 and 3. So it means that the cost has some effect. The dollar usage has some effect. Overall annual usage has some effect. Unit cost doesn't have any effect. So this is one of the important factors. So this confirms whatever the managers were doing earlier with ABC analysis is working fine. Dollar usage is one of the important factors, right? Next is 5, 4, 4, not much, right? 3, 3.6, 3.5, not much. But 5.9, 4.7, 4.4, there can be two segments which have got lead times differently, or critical factor differently, not lead time. So critical factor differently. Now we can visualize all of that. So we can visualize that, and this will be my segments. Segment 1, segment 2, segment 3, this is how it looks like. And I can take out only one segment and suggest what is to be done. I do not want to get deeper into this because all these things will be discussed in machine learning. What are the projects that we have mentioned in the right side? All of those projects will be handled in machine learning.
Okay.
So you should know what algorithm you are using when they do that.
Okay, sir.
How it is working below the hood.
Okay, sir.
Yeah. Okay. Let's go ahead. Some of you who can present, please go ahead.
Hello, sir.
Maybe, yeah. Yes, Krishna.
I did the second attempt.
Yeah, please.
So last time I got a feedback from you that it was good, but I have used so much of intelligence. So this time I try to make it a plain way, and
Yeah.
I want to represent it.
Sure. Please go ahead.
Yeah. Can you see my screen?
Yeah.
Okay. So this time it's my second attempt. Data is same. That's the Wisconsin breast cancer data from UCI. So I'm using the same data set. I just loaded it. Try to see some information. So this was common last time. This time also, I just give the common columns the proper name. It was available in the names file from the UCI. So this was the names file. Okay, anyway, I will open it afterwards. That's not important. There was only one this column which has some question marks, so I just filtered them out. So all the rows removed. And then converted this again back into the integer because earlier it was an object type, this one. Then again info. Now we have this 682 rows, so approximately 700 I can say. I did a data.describe. Same idea was that to see the min and max, so all of having a numerical value of 1 to 10. And last time I did some kind of removal of the columns based on some criteria, which ended me losing up some rows also because of the limitations of ROC, how we use it. But this time, I just here I'm just simply showing the data.head and the data.tail to see that everything looks proper again. I was trying to do some checks and that how the shapes and other stuff, but it has. Then simply I came here. There was this first column ID. It has no predictive power. It was just simply a number. The case ID. This was actually the case ID of the patient. So it was just dropped. Now again I'm seeing that what is the data. Okay, so now here I try to do something different. So I know that once I drop the ID column, then I have this class column, which is the dependent variable. And so if I try to create my features, then this will be Y and all of them combined should be X, right?
No, you cannot
So
combine all of them. You have to use them individually.
Yeah, I will be using it even individually, but then just bifurcate between the dependent and independent variable.
Yes, that is correct.
Yeah. So ID is gone, and now I'm just removing and trying to create a new data set. I will tell you why. So
Mm,
I just removed this class. Now what I'm left with only the feature variables. I'm
mm,
trying to create a new data frame for feature variables,
mm,
putting all the columns into this, and then I have a new data frame with only one column now, which has got only features.
mm, mm.
So with 8 rows and one column, only features. From the stats model, I'm trying to check the influence of these variables on the
I lost you for a minute. Lost you. Oh, do.
Am I audible now, sir?
You are audible now. Yes.
Okay.
We lost you for
So
about a
by
minute
this
or so.
enter, oh, I was simply saying that I created a new data frame with one column called features,
Mm.
which has got all these 9 column names as first
Oh,
of the
I
one
thought
column.
you are ranking them.
No, 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 no. I will come to that. Then I was
Okay.
trying to remove the multicollinearity, that if any one of the columns has been defined by other columns.
Ah.
So I just took the stats model from their variance inflation factor with.
Mhm.
Now I'm trying to calculate the uh, inflation factor for all of them, and I'm trying to drop those columns which are all are having the above 5 actually. So one by one. So for
Mhm.
example, this time I just put in the descending order. I see that this has got the very high number. So I will just drop this column. I will not take this into account. Once I did it here, that I dropped the class column, which was the dependent, and then from the independent one column.
Mm.
Again, I calculated this everything the same. I have one column less here now in my features, and then again I tried to calculate. So this time when there was not this column, only these 8, the highest number I got was 8.0.
Mhm.
I removed again this one also. Again, I did the same thing. Uh, Next was this blonde chromat in another column that I removed. Again, I did the whole stuff in this time in a single cell. This time, uh, this column single epithelial cell size having 5.8. Since I was looking for anything greater than width of more than 5 to remove, I removed this column also. Now I am left with only these 1, 2, 3, 4, 5 column, 5
Mm.
features,
Mm.
and this one. Okay. Now, so these are my final columns that I'll be using it.
Mm.
Uh, Only the columns, but the data will be complete and all the same. Then here I try to, instead of like coding and every time writing the column names in a list, I try to get the column names to a list and then appended the class again back. So I have the a column list with all my features and the dependent variable. So I created a column.
Mm.
And now I try to create a correlation function with it is just a correlation matrix, and then just I took out the class out of it and then sorted it, and then so this is how it looks. So among the remaining columns, this is how, so class obviously will have correlation with itself, but the rest of other 1, 2, 3, 4, 5 columns are like this. So this one is having the uh, highest correlation with the class. So this will be my first column. So as per suggested by you last time, I try to took one by one all of the columns and then try to get the dummies out of it. So this is the first candidate for me. The most important one was the bare nuclei. I have to comment here that start with this column because this has this high much correlation, and then I'm doing a one hot encoding for this column.
Mm.
So this is how it looks. Um, get a from the original data set, get all the rows, but only the column which I am worried about, and the
Mm.
dependent variable. Then simply I was checking something that how it looks. So this is how it looks now. The data one is my new data frame, and data one is why I named it, because one by one, if I get next iteration, I will take two columns, then I will make it as a data two to differentiate it. I don't want to lose this, so that's the reason. Now I did the one hot encoding by simply getting as a dummies for this column. Now the interesting factor was when I do this, you see that this class column, my dependent is already there. This column is not there anymore, which I don't want anyway. And then the one hot encoded from 1 to 10 values all have come here.
Good. Yeah.
So that's how it looks. Now I just
Yes. Now you do. What is your analysis now?
my analysis was, sir, I took the k value as 3 with the starting, and then 5, and didn't go 7 because approximately 700 rows were there. So
No.
I should not be going.
You used K means here, or you can do ROC, right? Directly you can do
I did
ROC.
ROC.
But
I
some
did
changes
ROC.
are required. The bare nuclei looks like ordered variable, right? You can divide this entire 10 into only 3 groups: less than 4, 4 to 8, more than 8. Whatever you have done for 10, you have taken the dummy variables, you can divide it into only 3 and then take the dummy variables only for 3.
Can be done, but right. But then since this is a medical data, and
No, it doesn't matter. We are not
I was
interested
fine
in.
with
Yeah.
I was
No,
fine with actually 10 different
because
variables for it.
doctors are the people who will not do anything which they don't understand. So we have to
Yeah.
explain them. That is okay. For us, it is only testing the algorithm.
Okay.
Yeah. Okay. Okay.
So actually this is ROC only.
Hmm.
So I just try to print my columns how it looks.
Yes, that's correct.
Yeah. So this was my uh, this data frame. These were my columns. After this was my original from which I prepared with the only two. From here I derived this dummy data frame. So these two are here just for my reference.
Yeah.
And I was not losing it somewhere in between. So that's the reason I just tried to write it here. Then I was trying to calculate the feature vector. So the feature vector will be nothing but combination of all of these 10 in the same sequence is how it looks. Last time I did some engineering here, but this time I didn't do anything like that. And it's simply the combination of all of these. So all of the 10 with the ones at the right places. So I have now a new column called feature. So this is my new vector. Now I have written a very small function to calculate the ranks and then simply multiplying with the power of 2 for each of them and then returning it. And then I applied it actually. Sorry, this is the series actually. So I did a map on it. And then applied this function with a map. I have a new column called rank with all of the unique numbers. Now I have my data prepared to calculate ROC. So from here, I did two things. The one I tried to make it, I tried to break it actually in training and test data here. So for the training, I took all the rows but one, and for my test, I took the last one. Now since I already have I didn't have to do the calculation of a rank actually here because I already had it. Now the test data's rank I subtracted from all of the uh, uh, data rows here, that is a 697 rows, to find the distance. So this is how it looks. So created a new column called rank df, and then subtracted with the subtract function which is already available, and then I just try to get the absolute of rank df and then assigned it back. Now here I try to get the, say if I am taking the k equal to 3, then I just took
Krishna,
head.
one clarification. Why
uh,
you use subtraction?
I will tell you subtraction is because uh, this was a complete I mean, this was a complete data set, right? So I just counted the rank of all. Now I had to, the final thing that output as per the problem statement was, we wanted the k nearest neighbor, right? So k nearest neighbor can be 1, 2, 3, 4, 5, 6, whatever you want. But how, on what basis you will calculate the nearest neighbor? The difference in between the ranks from the test data and the training data, right? So if this is my test data, yeah. So this is the rank, and then I subtracted it from the rank of all of them. So for example, I'm calling this as train. So you see that in my training data set, I introduced one more column called rank df, and then got the absolute and assigned it back. Uh, I did it all in one liner. Anyways, so now I have in my train one more column called rank df, and then I sorted on the values of it. And this time it's in ascending order. For the nearest actually, then if the nearest I want to number 3, it's the head of it. So these numbers first you see are the row levels, and this is the difference. So you see that all of them has a 0 difference. So head equal to heads 3 like this. Now I wanted to see that what is the predicted class of it. The class was already available to me. So this was my training data, did a log for it, and then took all of this thing so that I took the labels of it. And after this, I mean, these are the labels totally I'm getting here. These number 4932140 instead of typing here, I just got it automatically. Then dot class, and then did a value count. So you see here that um, 4932141 out of these, uh, 2 were having a class of 4, and 1 was having a class of 2. So finally, my prediction is as the mode is 4. So
That's correct.
yeah,
That's correct.
so
Yeah.
this is, and from my names dot, if I open this Wisconsin's, this one which was given, uh, class 4 is for malignant. So the predicted class is 4, but I didn't stop here. Then suppose that if the number, if you wanted the 5 nearest neighbor, so I took the k as 5 next time. I did the same stuff again. This time, this was the frequency count that for 4 records and for 2 ones. So again, the maximum of the mode is 4 itself. So again, it's the 4. Um, Also, if you see the data, I mean the row that I took, that I printed here, this one, this also had a class of 4. See, so the prediction was correct actually. Now there was a this time again I started from scratch again, but this time I took 2 columns with the maximum correlation out of the 5 columns identified after removing my collinearity. So the data set was on the top. This was my data frame. So I just took the index 1 to 3, means 1 was the class actually, so remove it because it will always be 1 to itself. Then the second number will be at index 1, and the so 1 to 3 will give you the 1 2. So these are the 2, right? And then I appended a class because this is a dependent variable. Then again I tried to create a, this time earlier it was data 1, now it's a data frame 2 from the original data set with all the rows and these columns, right? So this is how it looks this time now. Whatever I did, the same is being repeated here again, that I created a data frame 2 here. But this time, if you see, the pd.get get dummies is for where nuclei and normal nuclei. So this time you have 20 columns, and the dependent variable, and these 2 columns, original ones, dropped here. So this is how it looks. Now the 2 key power, the powers of 2 in the addition, the number will go very high here. So I just try to print out all the column names. So this is how it looks, all the column names. So you see that there are 21 columns actually. One is the class, and then 20 columns here. I try to create a feature column like I did earlier. So this time, and I just head of 1 I have written. I didn't want because it was taking so much of a space. If you see, this is the feature vector here. So all of those 20 columns, and then simply I already had written a function on the top to calculate a rank. So I just mapped it to calc rank. the same function is reused, which I used there. And this time, for example, I just try to put one of the records as a head of one I did. You see the rank is 2560. So now, so because there was 20 different columns here, so this was inevitable. It had to come. Now again, what I did is I had prepared a data set. I did break into the train and test set. Purposefully, I did this time that I broke it into all for the training and one for the test set, like this. The idea behind this was I'm taking the same column that I took when there was only one column, and we'll see the reason why I did it soon. So if you see this one, the last one was this much of rank it was calculating, and this one it's 8208. So earlier I believe the number was 8 and 16 here when there was only one column. Now I'm trying to do the same thing, calculating a rank in the training data set, another feature, subtracting all of them, getting the absolute values. Now here I have everything ready, so I can find the k nearest neighbors. So I just did a sorted the value ascending order, and then they head for 3. These are the row labels, and these are the differences. So 3 zeros. You see, these 3 are now different actually. Now I try to find the class of it. So you see this time all the 3s, 0, 0, and 8 difference, but all of these three data has got this value as 4. And we already know that now the predicted class is 4, which is a malignant, and test data also has this value 4. And earlier there was some 2 and 1 kind of thing was there for the majority with the 2, but this time with the 2 columns, when I take as a predictor variables or the independent variables, all of them, uh, I mean all of them were having class 4. So 3 records, all of them have class 4, which matches from our tested data.
So you are
Even when I
using
try
only
to
the rank of the DF for doing the k-means, I mean KNN.
yes, exactly.
Correct. Very good. Very good.
This is what it was written in the question also, sir.
Yes, yes, that is correct. This is what was expected. But looking at your code, it looks too convoluted. Simplify and stupidify the code.
I'm much more into one-liner, so
Okay, okay. So
yeah, so
normally if you
that's
are
why it
caught,
looks
the
that difficult.
chiming is not a good thing. So if possible, make it more explicit. Nothing wrong with that, right? As long as it is working, nobody questions you. But when we
I mean,
do
sir,
code review, we are looking only for the borderline cases.
yeah, but with me for the around 14 years of experience, writing this kind of code comes as natural to me. I mean, I am much more find myself very easy and a comfortable place if I see one-liners rather than reading 10 or 20
Good,
lines of
good.
code. I mean,
Yeah,
very
sometimes
personally.
what happens is you become too Pythonic, moving to another language becomes difficult. Let
No,
us say
sir,
you would.
I write into agnostic way. So I started with language C and then to Java and now in Python.
No, no, go ahead. It's always
And
good, right?
yeah,
Nothing wrong with that.
thank you.
Yeah.
And sir, this was my another attempt with the number as 5. I mean, K
Hmm.
as a 5. Again, the same thing here. I got these labels and the difference is 0, 0, 8, 12, 12. But if I try to find out, see, all of these 5 records has got a class of 4.
Hmm.
Earlier it was 4 and 1 with only
Hmm.
one variables, but this time with
Hmm.
all the 5 rows, same class. So predicted class is 4 as it has a max frequency. I didn't go for 3 rows after this because it will be same repetition, and moreover the power of 2 were keep on adding and it was becoming a huge number. So I just stopped here. But then I
No, that is
finally
okay
found
because
out.
Python can handle arbitrary integer. It is not a problem.
Yeah.
But it is to understand ROC. We don't go with ROC more than 100. More than 100 variables. In
Okay.
fact, already you have 10. 10, another 10 variables
Yes.
with 10 levels. 100 is done. Going
Yeah.
beyond that
Yeah.
is not good for ROC.
Yeah. And sir, adding to my learnings from my last attempt, that was, this is my attempt too. This one was my last attempt. So adding to this, I just learned one new thing, that was to calculate the width to remove the multicollinearity thing. So
Not
this is one
much
step added
effect.
learning.
Yeah, that's good.
Yeah.
But for us, something stitch in time is much better than a designer cloth. So go for quick ones within half an hour. If you can do this, good enough, right?
Yeah.
Good attempt. Okay.
Okay. So, sir, I will be submitting both of these files. The first one,
Oh, not just these files. You have to present the results as a PowerPoint presentation. So what is
okay.
the pseudocode? Write the pseudocode of what activities you have done, and what are the results you got in first version and second version.
Okay.
Then submit the code.
I will do that, sir.
Right? Comment all the code with good documentation and then submit it, so that others, if they want to follow, they can follow that. They may not be one-liners, no.
Sure, sir. I will try to. Rather, I would like to write some statements kind of thing in the English language.
Yes.
That's a better thing rather than code. And
Yeah,
then
comment it.
this IPNB file will be accompanied with it, so it will be easier to follow.
No problem. Go ahead. Good attempt. Good.
Thank you, sir.
Okay, Krishna, one day I'm
Okay.
going to steal your code. There is so much to learn from what you have written.
No, thank you. But you know what? I am also learning every time. I always have this thing in my back of mind that if I write in C or Java, I know that there are some kind of functions. I will just simply do the dot and then write it, hit it, get some error, and then I try to Google it out, and
That
then
is the way to
came
learn.
it's already there.
Make mistake and learn.
It's already there. Yeah.
Yeah.
So two things. One more, if you really want to know from the programming side, I learned that how to apply a function on a data frame and how to map a function on a series,
Chaining the methods. Yeah.
chaining the methods basically, and then
Yeah.
how to correctly use and when to use apply and when to use a map function.
Hmm.
So, and then this scalar operation called subtract on a data frame column. So I was also not aware about it, but then here
Oh,
while finding
sometimes
the
that
difference.
broadcasting, it uses broadcasting, that will
Yes.
backfire. So you have to be,
Oh,
but you can go for try and accept. So try whatever the method you are doing, except when there is an error, try to put only the last error of the stack. That will handle. Not that we would like to do everything according to somebody's thing. You should just try your own approach. If it is working, both of them are giving same results, why not? Or better
yeah.
result. Yeah. Okay. Good.
Thank you,
Anybody
sir.
else will be presenting it?
Can I go next, sir? Ganesh?
Yeah, please.
Okay. Sir, I did some change, but I'm sure you will have feedback on this too. I was under the weather, so not as much elaborate. So mine was that movies clustering and recommendation. Last time, your feedback was so I need not get into the one hot, and then I can use this itself as the data, right? So that was the primary feedback I had. So I thought I should convert the category to categorical values to numeric. So first I thought I should write function, and I was experimenting a lot with that. Later I figured out so there is a function called factorize, which will help converting this categorical value to the numeric. Is my
Excellent.
understanding right, sir?
Yes, correct.
Okay.
You can do it with multiple methods. Factorize is one of the methods.
Got it, sir.
Yeah.
I was uh, sorry. I think was it factorize or vectorize? I think it's factorize.
Factorize. Yeah.
Factorize.
That's go ahead.
Factorize. Yeah. Yeah. And I was a bit dilemma that whether I'm taking a shortcut here, but for me to understand the concept, this was okay. If I have to write a function to convert this into a numeric, that also I can attempt. But I don't think that was the primary objective, so I don't do that. Another small improvisation that I did was to dynamically create the binary vector in our ROC function that we wrote. So based on the column size, I can build a binary so that every time I need not go and change that vector with 1, 2, 4 816. I need not go and make the changes to the code. So that was a small improvisation I've done. One dilemma that I had when I converted the um, converted the categorical data to a thing is these numbers got converted into 000, right? So then when I pass to ROC, then I mean 0 multiplied by 0 like will result in 0. So that is one dilemma. But later, like I convinced myself like this will only fall into the cluster, and it's only a more gets into a cluster, not really
Correct.
a number
Correct.
of meaning.
Zero doesn't matter. Right. Zero
Exactly.
can be a cluster.
Correct, sir. Yeah.
Yes.
Yeah. So that all that one hot encoding which I had done it in the previous example, so it's not really relevant. This is what like I have done in the previous example. So here like I process remove the first column and then I pass it to our ROC function. Then I get these clusters 0, 5, and 7, and I mean I conclude like that 0 category corresponds to the family movies. Action, yeah, family movies. So which is what like my conclusion. So what improvisation can be done here, sir?
So, like Krishna did, taking up the movie dataset itself and taking couple of columns and doing it, and trying to see can it be done on a larger dataset is one thing that you can try.
Okay.
Right, so that it really works. So only the column matters. The number of rows doesn't matter. Is what you have to prove. Right.
Come again, sir. You mean to
So
say to take more columns?
more rows.
More rows. Okay.
More rows. Select few columns. 1, 2, 3, 4. Right. Reduce number of levels in each column. Right.
Okay.
If you want to use ROC, just because we have the hammer, we are running it.
Correct.
Right. Otherwise, there are better methods for doing this. Right.
True, sir.
Then
Yeah,
apply like he did the KNN on the final value that you get for the rank. So whichever is the nearest rank, get that and demonstrate for this rank the best recommendation is this, next best recommendation is this, next best recommendation is this, based on the probability. The probability you can find by for that particular rank how many movies are there. 100 movies are there. Movie 1 is 60 times, movie 2 is 30 times, movie 3 is 10 times out of the 100 movies. So it means that movie 1 recommended with 0.6 probability. If he has already seen that movie, you will go with movie 2 which is with 0.3 probability. If you have seen that movie also, you will recommend movie 3 which is with 0.1 probability for that group, because he has seen both of this. The chances are high that he will see that movie. Okay. Right. So I want you to come out with the next best recommendation, a set of top 3 or top 5 kind of thing if possible.
Sure.
Yeah. Okay. Good attempt.
Yeah. Thank you, sir.
Can I do next?
Yeah. Please go ahead.
So let me know if you can see my screen.
Yes.
Okay, so this is my data set. This is like the t-shirt data set where the heights are given and the weights are given. So to process for the ROC, what I did, I put it in the 3 bins. For the height, I put it in the 3 categories and weight also in the 3 categories. And then I manually converted the data because I can go for the programming to put the data into 0, 1, but I just went for the shortcut for now. And then I can show this is my I showed both the method, the KNN and the KNN as ROC. So in the KNN, when I am reading the data, so this is my function defined, and then I am reading the data. I dropped this non-numeric column, which is t-shirt size and the serial number. I dropped it. Then I called this. I wanted to suggest like which t-shirt size I can predict for the height 161 and 61. So this will become my new vector. I pass this new vector and my complete data set. And then I use Euclidean distance method to identify the KNN. So this is my Euclidean distance function. and then I'll get all this distance. The
So
Euclidean
what
distance.
you actually you're using on the all data set?
Yeah, yeah.
No.
This
You
is
have to use it only rank. You have to use only on the rank.
no,
Because
no.
all
I'm
other
just
things is
printing. I'm
pre-processed.
just printing. Just for my understanding, I'm printing.
Okay.
This was the height, this was the weight, and this is the ROC. So just for
Okay.
my
That is the
understanding.
rank. Okay.
Yeah, yeah.
Okay.
And then again, I'm clubbing just to see like, okay, what was the size, what was the weight, and everything. And
Euclidean distance with respect to what? With respect to the rank?
yeah.
Okay. Where is that code?
Is this KNN, right? Not the ROC.
No, no, no.
No.
This is KNN. First, I'm showing the KNN.
The Euclidean distance, I guess.
Yeah, yeah. So this is like the Euclidean distance, and then which is the then I am sorting it. This is my sorted result,
Mhm.
and then I am getting this. Like the my first, like I'm taking K as 3, so it will show me the K 3 nearest neighbor for the
Mhm.
height 161 and whatever the weight was. So this is my data for the top 3 rows, and the predicted size is n, which is correct.
Oh, but you are showing top three. If three are not there, what will you show? We have to show only two. Can you show me the code where you had written how you are computing the Euclidean distance with the rank?
Yeah, this is.
So, something.
I am deducting the new vector matrix with the full data set.
No, full
And then
data
we
set
square.
is you are using all of them. You are
Yeah,
using all
yeah,
of them, but
yeah.
you have to pass only one variable. That row, that column is rank. How are you calling KNN function?
KNN, okay,
Come
I'll
down.
show.
It is same. There is no difference. But I do not want to use all the variables.
This one.
I want
I'm
KNN.
calling here.
No, you cannot use both the variables. If you are using both variables, you are actually implementing KNN on both the variables. We want you to develop the rank based on these two variables. You have to create the rank. You do KNN only on the rank and see how good it is.
So in the Euclidean distance, I
No,
need to.
no, it has nothing to do with distance. You can use Euclidean, you can use city block, you can use power distance. You can use any distance, doesn't matter because there is only single column. Distance won't matter. Euclidean distance matter when you have more than one column or more than one variable. You have to go for Euclidean distance. Otherwise, distance is of no use.
So for me, there are two variables, height and weight.
Oh,
Based on
you
that,
first you have to
it will
convert
decide.
that into rank, right? ROC rank. Where
So
is
this
that?
is what this is my ROC rank.
Which is ROC rank?
This one. The Euclid distance is nothing but the rank.
No. Euclidean distance is not ROC rank. First, you have to convert ROC. For conducting ROC rank, you have to convert that into 1 not encoding, right?
Okay. No. What I was saying, I implemented this as a pure KNN. Now
Yes.
this is my ROC as
Yes. Okay.
this one. Okay.
Okay.
I did not get it. So this is my function,
Yes.
and
Mm.
here I will read this one hot encoded data,
Yes.
and then I'll convert into NP array.
Mm.
Then I called it, and then this is my ranking.
Yes.
This is
Now,
my
based
ranking.
on this ranking, find the KNN.
Yeah, yeah. So then I given the new height. The new
Mm.
height is 161, so which will go into height 2 column, and the weight is
Yes.
61, which will go to W2 column.
Yes.
So this is my new, and this I passed it. Then I again calculated, and my ROC came as 18,
Yes.
and this 18 is matching to this one row.
How many? Only one?
Only one.
Yes. That is the recommendation.
Yeah.
Right? So now we are telling ROC can be used as KNN only on one variable because all of other variables are abstracted as rank.
Mm-hmm.
Isn't it? It is abstracted. It is converted into rank.
Yeah.
Rank
Correct.
contains all the variables.
Yeah. Yeah. Correct.
Right? It's a new variable which we have created.
Yeah. Correct.
So that's one of the points that we are trying to drive home.
Yeah.
Right? If there are, for example, for 20, there are more than 2, 3, t-shirts. So in such cases, you can recommend those t-shirts if it is 20. For some, it's only one. It can be only one. For 10, there are 5.
I mean, fortunately for the data set which I
That
got
is
from the
okay. That's
internet,
okay.
yeah.
No, no, no worries. That is not a
And
problem.
this is my PPT which I started. Okay, so this is how it will go: problem statement, development, as is process. So just the explanation, and this is what I'm doing: load and pre-process the t-shirt data, then read and convert the process data into one hot encoding matrix for different categories of height and weight. Read new height and weight, find record which are similar to as is test data, recommend.
But you are
And this,
presenting it as a business case, not as a technical algorithm.
I'll show you in the
Okay. No,
next slide.
we just
So,
want a flowchart or a
okay,
series of. That's okay. What you have done is right, but your presentation looks more for marketing department.
so this is the which I found in the PPT. So I thought okay, let me put it in the 1, 2, 3 here only.
Okay. Okay.
And this is as is process with the current data. Just we need to go to the store and check the size and everything. I just put it. And with the possible state with the idea implementation, no need to go to the store. Reduce rate of product return for the e-commerce site and happy
Oh
customer.
yes, this is for the CEO. Why he has to purchase your thing? Okay, what I'm interested is what is the classification accuracy on KNN? What is the classification accuracy on KNN on ROC? Right,
Okay,
you have to add that.
I'll
Take
do
the
that.
training set itself, test it. If you
Hmm.
use the training set as test set, and if you recommend it, how good the KNN is, how good the KNN on ROC is. If they are same, I prefer KNN on ROC because KNN is computationally heavy. Every time you have to compute Euclidean distance or a cosine distance, which is very costly for me. Right? I can do ROC, and if the results are almost similar or 10% this side or that side, still I will go with ROC. Okay.
Okay, and these are the
That's
slides
okay. That's yeah.
just to calculate how we'll
Okay.
go,
Good. Good.
and
Good.
the result is
Yeah.
same. This will come same.
Good. Good attempt. Yeah. Okay. Anybody else?
Yes, sir. I can present it.
Yeah. Please. Please, Kaushik.
So next week is both quiz and the exam. Is that right?
Yes. Quiz will be for half an hour. Maybe you can take it anytime, or you just tell the time because all of you have to take at the same time.
The quiz will be like online.
It is online
Questions?
MCQs.
Okay.
Yeah. So you plan for that. Tell Ajin. So he will do it accordingly.
Yeah. Okay.
Okay.
Yes.
Okay. Go ahead. Yeah.
So my problem statement is given the age and gender, we have to predict whether they are interested into cricket or football.
Okay. In India, we say cricket. There is no football. Maybe
Yeah.
this is for UK.
Yeah. Other than India, everywhere, I guess.
Okay. Go ahead, please.
Yeah. So this is a actual data set that we have, and
Mhm.
is like I'm just converting this age into multiple groups.
Is
So
this what you have generated randomly, or is data available anywhere?
the data is available. There are some 20-50 sets. I bring only few 4 or 5 samples.
You do that for the whole data set,
Okay.
right? And refer which is the data set you did. That gives more credibility than because we are doing this toy sample in all our sessions, right? We
Mhm.
take only toy sample data set and we try to do it and all. In the assignment, you go at least 25% beyond what we do in sessions.
Yeah, sure. Yep.
Okay, go ahead.
So here I just send age group. I just divided into the age group. As of now, I just considered the each mean size as a 10. So 0 to 10 in one group, 11 to 20 in another group. So that's how the group are distributed here. After that, I just go ahead with the one hot encoding for each groups, group 1, group 2, group 3, and gender column as well. So this looks like my input vector from group to gender. and then I just applied the binary vector, and this could be looks like this is the input vector only. So input vector is nothing but these vectors 0 to 1, the age group to this. And after that I just applied the ROC weight for each of the vectors. So just vector multiplication only, I got this kind of weights. Now there is a predictions comes, like I have a new edge and the gender. Now I have to what is the target variable for this.
Yes.
So for that I just already calculated metrics are there, and for fully vector, basically what is the input vector, I just calculated that based on the similar kind of approach. So I got this 40 as a ROC weight. Now I have to calculate the ROC distance basically. This is how the distance looks like for the last row. So ROC weight is 40 and others weight is like that. Then just distance is nothing but this is the reference point, and I have to just subtract from each of the weights and the absolute value. So this is the pretty much near value, and these are the corresponding the values that I have. And after that, what I have done is I just pick the three nearest values from the reference point and try to find out the probability, whether what is the probability he is going to play cricket and what is the probability he might play for the football. So that is the probability that I have taken. So based on the three values, nearest three values, it could be six. So now if I go here, so somewhere cricket is coming as 66% and football maybe 33%, because I took
Yes. Yes. But what is your recommendation? Because
yeah.
people normally don't like do this 66, do this 23, do this 10. They get confused and tell me one thing I will do, otherwise I don't do. What is your recommendation?
Yeah, so my recommendation would be cricket.
Cricket. So maximum of any of the vector is what you recommend.
Yes.
Right. That's how human brain works. Okay. Good. Yeah.
Now if I go to the code, so this is the vector, the data frame that I have. Here I've implemented the vector multiplication functions. Here what is the function will do, what is the input and what is the output from the functions. That's how I just write it, so that it would be easy who is going to review the code or who is going to have a look into it. So this will get the binary vectors. So based on the it is some kind of automated, I can say. No need to manually trigger what is the input
We are
vector.
not able to see the screen,
Oh,
code.
sorry, is it?
Still,
Is it? I can see.
I am not able to see.
No
Code.
code. Code. We are not able to see Kausik.
Oh, sorry.
Maybe you have to share that. Yeah.
Let me show. Sorry. Yeah. I think only one screen is getting shared. Yeah. So this is the ROC code basically. Able to see now, right?
Yeah. Yeah. We are able to see.
So the first one is the just a data frame, and here started implementing the rank order clustering. So first one is the vector multiplication. Here I just give the what this function will perform, what could be the input for this function, and what could be the output. So for each functions I have mentioned it. So get binary vector. So this will automatically generate based on your input vector size. It will generate the, suppose the length of the vector is 5, it will give you the 5 input binary vectors. So that's how the function written. And now this is one function for the one hot encoding. This is for the ROC function. So this will calculate the ROC weight basically. And this is the heart of the algorithms, I could say. All the functions are mentioned here, and each of the function would be called from here. So let's say for ROC function or ROC weight, if I wanted to get it, I will get it from here only. I'm calling, and then I'm just giving here the predicted value and just calling this main functions, and there are some prints are there, and actually we will get the distance and all like that, and then we will get at last the predicted value.
Okay. Yeah. Good attempt. Good.
Yes.
Yeah. Anybody else? Okay. Please try to complete as early as possible. Those of you who have complete, yes, go ahead, please. Yes, Srivalsa, go ahead, please.
Yeah, hi sir. I'll just share my screen.
Yeah, yeah, please.
Hope it is visible.
Yes, we can see.
Yeah. Uh, so I have taken a simple problem actually. We have a skill management matrix in our companies to assign the project and all actually.
Mhm.
So this is the data I have created manually, like not any source or anything.
Mm.
So a rough data actually.
That's okay. All data will be similar to this only, no? It cannot be different. Somebody cannot have no degree, but still he will be the project manager is impossible. Next to impossible, if not impossible, isn't it? That's okay. You can go ahead with this data.
Yeah, so like education qualification, I have like three varieties: UG, PG, and diploma. And even experience, I have four varieties, like 0 to 2, 5 to 10, and 10 plus, and 2 to 5. And skills I've taken just yes or no, like I can have any skill, like Python, yes or no, something like that. So this is what I have thought of, and to get for a
But what will
particular,
you predict here?
yeah, but if I have a project requirement or something with particular skills, like I should be predicting which employee would be like suitable.
Then whether the education qualification experience, does it matter?
Actually, not. It would be mostly skills
Yes,
actually.
isn't it? Right?
Yeah,
So
yeah,
that basically is feature selection. You can have hundreds of variables, nothing wrong with that. But you have to be very careful. As I was telling you, I always tell I am least bothered about what is successful. I am quite interested in what is a failure. Why my AI algorithm is failing is more important to me than how good it is.
yeah.
Right?
Got it.
So go for feature selection and improving the algorithm. Okay? Yeah.
Okay. Oh, then for now, like I have actually even done with that, like created this one hot encoding for everything actually.
Hmm.
So I'll just go to my code. Not done so much actually, just started with it.
Hmm.
Uh,
Yes, visible.
okay. Hello.
Yeah, yeah. Go ahead, please.
Yeah, so I'm just reading the value, and here like I have yes or no, so I am like just converting it to 0 s and 1 directly for
Hmm.
the skills column. And here actually I was thinking of using these two features also, like education qualification and experience. That's why I was doing like one not encoding for these columns actually. Maybe I'll remove that.
Hmm. Okay. Yeah.
So with that, and I dropped employee name actually because
Correct.
which
Hmm.
is not needed. And then I'm getting that matrix actually in the, then actually I'm getting the ROC that I have written it as a different function. So I'm going through the metrics, and actually of two different function equally. So this is for actually getting the binary vector according to the length of the matrix. I'll be getting the binary vector, and this is like ROC. We are getting the multiplied sum and the row,
Hmm.
complete row.
Hmm.
So for each row I'll be doing that, and then I'm sorting it. Then the sorted, here what I'm doing, like I'm doing it in a loop that I have read, like we should be doing it in a loop, and when there is no change in the order, we should be stopping it. The
Hmm.
ROC calculation. So I'm just checking whether the sorted thing is fine. If it is, then I'll be stopping it. Else I'll be continuing to do the column sorting. Actually, I'll be doing the transpose of the matrix. Then I'll be like doing the same thing what I did for the column rows for the column also. Then I'll be continuing the same till I get the there is no order change in the column. So I'll be getting the final matrix from here, actually, from this code. This is what I have come up. So I was thinking, so from this matrix, I should be associating the column names or like employee names also with this. So, and I should be doing like prediction from this matrix. That's what I was thinking.
And one of the things that is missing is performance.
Okay.
With all the skills, if you are
Okay.
looking at the HR recommendation, if performance is not there, don't recommend that person to this, because AI will be in problem. They say AI recommended, what can I do?
Yeah, got
Actually, it is not AI which is recommending, because we are not included performance as the variable. Whether they ask or not, add performance as one of the variable.
Okay, maybe I can drop these two, like education, qualification, and experience, and add the performance.
Yes, 1, 2, 3, 4, 5. Right.
Okay.
What do you do with a guy has all the skill but his performance is 1? Would you like to have 100 such people in a project?
Okay.
Right. Okay.
Okay. Yeah.
And actually, you can also add the feedback from the customer also. Good or bad, something.
Good, bad kind of thing. Yes.
Our previous project which they worked.
Yeah, all the projects. So far, they have 2, 3 years experience with the company. Outside the company, we may not know. But if they are homebred, homegrown, performance is good, feedback is very positive, they are the people we would like to have in our, even in my project. Anybody who complains everything except himself is a big problem for me. So for me, I always blame myself because I'm not good. I'm not really understanding what is happening. It is not system. It is not other people. It is me. I'm not able to manipulate the system. I'm not able to manipulate my manager, my team. So I'm bad. Not my team manager is bad. My system is bad. My customer is bad. He blames everybody. Right? That is what we would like to look at. Okay, good one. I think last time we had another gentleman shared similar kind of thing, right?
Yeah, that is me, sir.
Guru. Okay. Yeah. Yes.
Yeah, I'm yet to implement that, sir.
So she already implemented it. Okay.
But mine is more classification of the performance.
No problem.
Recommendation.
No worries. Yeah. No worries. This basically is a prescriptive analytics. What she has done is prescription. It is not classification or clustering.
Yeah.
She is trying to recommend who are the best skill set or what is the resource which is having best skill set, best performance, and best feedback to the project. Availability and non-availability, and it may be a feeder for others also. What is the expected skill set, or what is the kind of performance that we are expecting? So what soft skills that guy has, can it be translated to others, is the problem HR has to look into once this is generated.
Okay.
Yeah. Good. Try this. Probably speak to Shinu once, right? We would like to test this model, whether it really works, or is it some kind of theory we are trying to propagate.
Okay, sure.
Yeah. Okay.
Yeah.
Good.
Thank you, sir.
Okay. So anybody else? Okay. Those of you who have presented today, please submit the copy as is copied today. Ajin, you just take a look at it and get that. Once you build all the bells and whistles, you can submit it next week. Right, let's close everything next week. Others who are not done, please submit as early as possible before next week. Okay.
Sir, suppose if we submit something today, will it get locked for those people who submitted, or will it allow?
No. Just we would like to see that you have submitted today. It's for records. Sure. It is not evaluated. What is evaluated will be till next week. After your exam, what is there will be evaluated. The final version which you are submitting after the examination will be evaluated. This is not evaluated. This is for records that you have done this. Okay.
Sure, sir. Yeah.
Okay.
Sir, maybe I may be repeating what I asked before the presentation by one of our colleagues here. The exam format, so because like having written the Python module, Python 1, what is the format we can expect here, sir, and what will be the duration?
Yeah, basically duration will be for 3 hours, and it's an open book exam, and you can copy the code, you can copy anything that is available, because for me it is more of your thought process and your ability to think beyond the code. It has nothing to do with code. You can copy the code what we had in the session, but the problems, each of you will get a different problem. So you have to solve a different problem. You have to implement some algorithm and try to take it out, and some twist will be given in one of the algorithms. Let us say that in linear regression algorithm, I would like to add some twist. That twist you have to implement, which is not done in session. We have not done anything. It's a thought process. It has nothing to do with whether results comes or not. What is your thought process? Right. I am trying to check what is your thought process, how meticulously you are thinking about implementing AI. Like we saw, everything is good, but she is recommending me all backbenchers who want to tell the manager what he has to do. Becomes difficult, right? Adding one variable would have solved that problem. That is the thought process I'm looking at. Because AI is about feature engineering. AI is about reasoning. So LA is just one kind of subject, but I'm looking from the higher perspective. If we are using this in AI, what is that I should look at? You can always implement any LA algorithm, because most of it is calling some function. And if I say no, you have to remember it, I will be testing your memory, which I never do. Right? We don't test your memory. We test your capability to think and implement. Right? So maybe about 3 questions will be there, and 1 question will be actually theory, and 2 questions will be implementation of some algorithm and data. So you have to come out with your results. Why your results are better, right? What is that you had done? Let us see that.
Okay, got it.
Okay.
Yeah. So you clarifying that number of questions help. Will you mind sharing a sample question paper from the previous batch?
Oh yeah, sure. Yeah, okay. Ajin will do.
Okay.
Yeah,
sure. That will help.
Okay, good luck team. Let's connect next week, right? Do well, study well, stay safe. Yeah.
Thank you, sir.
Yeah. Have a nice weekend. Bye.
Bye, sir.
Thanks, bye.
Thank you, sir.
Bye, sir.
Bye.